However, we're here. Welcome to this episode of Inside Unreal, your weekly show where we learn, explore, and celebrate everything Unreal. Today, we're going to talk a little bit about the movie render queue enhancements that has been done in 426. And to help me in this endeavor, I have Andy Blondin on the call.
Hello, everyone.
As well as Matt Hoffman.
Hello.
Take it away, guys. The floor is yours.
All right, so we're going to be talking about some of the enhancements we made in Unreal 426 to the movie render queue. Andy and I will be going back and forth as we go through this. Andy will be giving us some more context to a lot of the things that you're able to do, and I'll be handling some of the more technical side as we go through here. So if you haven't seen the movie render queue feature before, it's designed to be a replacement for the current render movie feature in Sequencer, which is unfortunately a little bit similarly named, but the new one is now the movie render queue. The big difference between the old one and the new one is that the movie render queue can actually accumulate the results of multiple renders to produce a final image. And it's going to give us a lot of different benefits between like reduced noise and ray tracing and better motion blur. Another thing that's now possible within the movie render queue is adjusting your settings to be higher quality during the render. So you can pick high quality settings that maybe are not viable for real-time editing, but when you go and actually render them out, you can then apply them. One last big change that we've made is that it's now designed for Python scripting. So it's much easier to integrate into pipelines and other workflows that you might be using that are driven by Python. Okay, so this is the table of contents. We have quite a bit of content to go over today. So we've actually broken it into kind of two parts. The first half of this presentation will be new things that we've added that kind of apply to all users, improvements. And then the second half is going to be more of the kind of post-production workflows that you may be able to do now with the new movie render queue. So we'll be going over the basic usage first. We'll be talking then about some of the settings in the various or the settings for each job. We'll talk about being able to save and load queues, which is a new feature in 426. We'll talk briefly about scripting support. We don't want to go into too much detail as we don't want to get all technical, but we're going to make sure you guys know what's there and what's available to you. We'll be talking about improvements we've made to the EXR output. It's much more powerful now than it used to be. And then finally, the last one on the first section is we'll be talking about troubleshooting issues. So there's common issues that we've seen people having over the course of 425. We've put together kind of a list and some possible solutions that you guys may need to use for your projects. The second half of this, we're going to be talking about the new ObjectID pass, the Stencil Layer feature, and then OCIO, which is a color management system. And then finally, we'll be talking about accessing the GBuffer, which is again a new feature in 426, and then best practices for different workflows. So for 426, we looked at what people were doing in 425, and we found that licensees from many different industries are using it for very diverse use cases. So we've added a lot of features to the various, we've added a lot of features to the movie render queue. And what this means is there's now a lot of options. But one thing to keep in mind as you go forward is that the options are there for different people, and it's unlikely that you'll be using all the options at once. So you're going to want to keep that in mind as you go through that. You may not need some of this information, and you don't need to worry too much if you don't understand it. So if you haven't seen the UI before, this is what the UI looks like. In the bottom right, we have Sequencer, which hopefully you're all familiar with. In the top right here on this window, we have the movie render queue. This queue has more than one job, and it allows you to configure the settings for a job. You can have multiple jobs in a queue, and when you render them, it'll render all of the jobs in the queue. The reason for this is so that you can do more batch work, creating jobs, using different settings on them, trying them out, put them all in a queue, render them, and you'll be good to go. Finally, on the left-hand side here, we have the settings window, and this is where you'll be configuring the settings for a particular job. Up next, we're going to have Andy give a demo of this UI in motion, so it's a little bit easier to follow.
Cool, you guys can hand it over to me. I want to go through some of the basic operations for you guys. And so the first thing to know is you're going to want to come up to the plugins menu and enable the plugins. There's two that you're going to want to enable. So I'll search for movie render queue, and you'll see that there's a plugin just called Movie Render Queue. We're going to go ahead and enable this. This is off by default. And then we're also going to want to turn on these additional render passes. And so check that box and turn those on. It'll ask you to restart if this is your very first time in the project turning it on. Go ahead and do that. And then from that point, you'll see that we have a new movie render queue under the cinematics window. And if I pop this open, typically it'll start like this, a blank queue. And it is just that. Basically, we can take jobs and submit them. And so this works off of sequences. So if you click the little render button, this will filter the whole project for all the sequences that you have. And we can either do a master sequence or we can do individual level sequences. And so I'll go ahead and add those in. You can see here that this is comprised of the 4 different shots that I have. That sequence I have open here, so all of these shots. And we have masks to be able to turn on and off shots. So if we just need to re-render the last 2 shots, we could do that. Or you can simply drag and drop these same shots from the content browser and do these as an individual job. So it's a nice way if you're rendering a big cinematic, let's say, and you needed to do 18 different shots or something, you can just re-render individual shots if necessary. And with each shot, I should say at the very top layer, there's this idea of settings that we want to use to be able to render, and that's what we'll be going into great detail later. So I'm going to pop this open shortly and just show you a few of them. But you can see that this is comprised of a sequence and a map. And so when I drag in the sequence, it tells me which map I'm using for that sequence. I can go ahead and give it my name and re-render. And some of this is stored in the metadata of the job. In fact, we can go ahead and load full queues. So this whole job here, we can go ahead and save this as an asset, which lives in the content browser. And so if I select one of these other ones, you'll see here that I have different queue that holds all the settings for that particular job. And those show flags that we have here. And if I click into the settings, you can start to see the settings for each individual job is comprised of 3 things. There's individual settings that we may want to affect, like the color output, some of the burn-in options. There is our output, so the form of media that we want to use, and then there's render options. And so Matt and I will kind of go over those in great detail. But in a typical workflow, one of the things might be, some of the settings that we want to touch on is, some of these anti-aliasing settings, for example, going into the sample counts and what that means. So once we've saved those or set things up we can save this as a preset as well. So you can see I have like an EXR high quality, I have one for the master, I have one for open color, and you can simply change those the global level for the whole master sequence, or we could change those at a shot level. And if we wanted to override, we can save out configs for that as well. So it's very, very flexible in terms of being able to batch process and render individual shots or full cinematics. And then lastly, we can click render local here. That would pop open this sequence that I have open here and render each of these individual shots. But to kind of save on time, I'm not going to click through rendering at this moment. So I'll hand it back to Matt and we can kind of dive into more of the slides in detail.
Cool. Thank you, Andy. One thing I did want to call out that I noticed while Andy was doing his demo is in 426, we've changed the design of the queue a little bit. The information such as job name and which sequence it was used to be part of that dropdown. Now that has been removed and the dropdown only contains a shot list. Details like the sequence and map have been moved to a details panel on the right. So it was just a nice quality of life improvement, made it much easier, much better for people. And again, we'll be going through all the settings in more detail. Andy was just giving kind of a quick overview of what it looks like in motion. Okay, so we're going to talk about the individual settings as we go through here. These are documented pretty well in the actual online documentation. We go through each property in the online documentation, so I don't want to spend too much time talking about every property that we have here, but we'll go ahead and talk about kind of what each setting does and what you might use it for to control things.
Hey, Matt, sorry for interrupting again. Could you restart your stream, potentially even rejoin the call? We're getting a little bit of poor bit rate from both your voice and screen share.
Okay, that was relaunching the slideshow there. Is that enough, or do we want to join and rejoin the call as well?
Let's see. I'd say go ahead and leave and rejoin real quick and see if we can get your voice quality up as well.
All right. How about
See if the internet gods are with us today.
hopefully they are.
Still sounds a little choppy, unfortunately. You want to turn on your camera and we'll see if...
Test 1, 2.
All right, well, we can at least hear you. So let's hope it kicks up in quality.
Okay. Sorry about that, folks. You don't control the internet these days. So talking about the output setting, the output setting is kind of the high-level control, such as the file paths and resolutions. So it's going to be things like, where do you want the files to go on disk? What resolution do you want the stream or the video file to be? One of the things that you can do here is there are some optional overrides. One that I use a lot personally is the use custom playback range. And this is if you just want to render a couple frames out of a sequence without rendering the whole thing. This is so that you don't have to go in and edit the playback bounds of your master sequence and sequencer. You can just come in here and say, for this particular job, only render frames 7 through 9. New in 426 is we've added a version token. The version token, as you can see here in the file name format fields, is you can use things like temporal sample count, the sequence name, or the frame number. So in 426, we've added version. Version is controlled by the settings down here. By default, it's set to auto version, where it will look in the output directory for a version folder name already. And if it finds one, it will just increment the version for you and make out a new render. If you turn off auto version, then you can specify the version number specifically. Okay, the next category of outputs is the image sequences. This is generally the main output that we use. You can output bitmap files, JPEG files, PNG files, and EXR files. The bitmaps, PNGs, and JPEGs are all 8-bit data. So this works pretty good for most of your workflows, for your creating trailers, things like that. For the more advanced use cases we have, which is most of the second half of this presentation, you're generally going to want to stick to EXR. For EXR, we say that it's a 16-bit EXR because the precision on the GPU for most of the rendering process is only 16-bit. When we do have 32-bit data, we will store 32-bit data in the EXR file, so don't worry about that. All right, so new in 426 is we've added support for the Apple ProRes format. This now supports up to 12 bits of data, which depends on the ProRes codec. You can look on the Apple website to find out more specifics about each codec that ProRes provides. One thing to keep in mind is that not all third-party software supports all ProRes codecs. So if you render out a movie and you try and play it in VLC or your favorite playback and it doesn't work, try using a different codec. You can either output one file for the whole movie, or you can do it per shot. It's going to depend on what your file name format is in the output tab. So if you were to just make your file name output, say, the level name or the sequence name, it would put it all into one file. But if you use the camera name somewhere in there, as you change cameras in sequencer, it's going to produce multiple files. One other thing to keep in mind is that it doesn't support audio output right now. So even if you render audio, it will not be embedded in the ProRes file. Also new in 426 is support for the Avid DNx format. We have both DNxHD and the uncompressed format. This does only support up to 8 bits of data, and like ProRes, it also does not support audio output. The burn-in setting. is an overlay of information on the sequence. You can see here in the bottom left, there's an example. It's the top bars on this is the shows things like the job name, who rendered it, what your branch is, what frame you're on in the master sequence, and what frame you are on the shot. This is baked into the JPEG, PNG, and bitmap outputs. It'll automatically composite them together, so your final image will just have the burn-in information put together with it if you have burn-ins enabled. If you don't have burn-ins, if you're using EXRs, we do not bake it in because we now support multi-layer EXRs, which we'll talk about more later. Burn-ins are kept on a separate layer from the main image in the burn-in. So you'll need to composite that together if you want, but that way you can look at your image with and without the burn-in information. By default, we ship one burn-in style, which is the one that you can see in the bottom left. But this is actually replaceable with your own widget. And the way we recommend doing that is going to the default burn-in that we provide, duplicating the widget, and then rearrange the elements as necessary. And then you can simply choose it in the burn-in class dropdown here on the top right. Once you do that, it will use your burn-in instead of ours. So you can put any information that you would like, and you can also retheme it to match your particular project. Okay, so for the camera setting, new in 426, removed in 426, we used to have a shutter angle override in the camera setting. And what this did was it overrode the amount of motion blur that you had. In 426, we have removed this setting. And the reason we've removed this setting is that the information is now pulled from the camera that you're actually looking through in Sequencer. And this is how the rest of the engine works. And this is going to make sure that your renders match what you see in the editor. So if you were using that before, now you'll just need to go to your cameras in the sequence, go into their settings and change the motion blur amount. In the camera itself, the motion blur is from 0 to 1. So 0 being 0 degree shutter angle and 1 being 360 degree shutter angle. We use 0.5 by default, which is 180 degree shutter. The other option here in the camera settings is the shutter timing. And shutter timing is a way of biasing the evaluated time range in Sequencer. This is a pretty advanced thing, but this can be useful for different industries who have different ideas about when you consider a frame. As some people might say that a frame ends, a frame is after the data. Some people might say a frame is before the data. So that setting will allow you to adjust that. I'm going to go ahead and turn this one over to Andy here to talk about color output a little.
Yeah, so on the color output tab, as Matt had mentioned, we've added support in 426 for Open Color IO. So Open Color IO has been in the engine for a couple releases now, but we've added it in 2 different places this release. One is you can add it into the actual viewport, so you can see the content with Open Color IO config and a LUT applied to the viewport. But you can also now render that out in the media. And so you can see in this slide, there's a color output tab that you can select. You have to feed it an Open Color IO asset. And in that asset, you typically define a source and a destination color space. So as things are rendered in linear inside of Unreal, you may need to output the media and have a different color management. And so you could say, need to match a film plate, and that could be like an RE log footage, for example. And so this is a good way to apply that on the render. You can also disable the tone curve in this section, and I believe when we enable the OCIO config, it disables the tone curve, which will allow you to render in full linear output. And so it's one of those workflows that's used very common in the effects and some of the post industries. So we're happy to add that this release.
Thank you, Andy. So as Andy mentioned, the disabling the tone curve there, OCIO is a pretty advanced topic, and most projects are not going to need it. So you can leave that disabled, but if you just need Unreal to output in linear data, you can just use the disable tone curve option. And this is going to output linear sRGB data instead of applying the tone curve, which is going to recompress you down to the 0 to 1 range. This disable tone curve setting used to be in the output tab, and it has moved to this new color output tab. So you can see here we have output and color output. So if you did have it set in the output tab previously, you will need to go into your configurations and re-enable it here in the color output tab. Okay, one of the other settings we have is the console variables tab. This is not new in 426, it's pretty much the same. But what you can do here with this console variable tab is automatically apply certain console variables when the render starts. And the reason that you might want to do that is you may have particular settings for quality that are too expensive for real-time editing, such as more bounces on your ray tracing, higher quality reflections, things like that. And they're too expensive to edit in real time with. But when you go ahead and render it out, you want to apply them. So this allows you to put these in here in this list with their new value. We will automatically store whatever value you're using in the editor. We'll apply the new one here, we'll render, and then we'll restore it at the end. For the console commands, you can use these to call custom events on actors, and we will call them the start ones before and the end ones after. The reason that they're not combined like the console variables are is that because they are commands, they don't have any previous value for us to store. So you will need to manage both the start and the end separately. Okay, the game mode override setting. This is going to override some of the game engine settings with better defaults for movie rendering. One of the big ones is we're automatically going to apply the cinematic scalability quality. The other things that we do by default is we disable texture streaming, we disable LODs, HLODs, and we improve some of the shadow quality settings as well. So this actually differs a little bit from the other settings. Most of the other settings, if you don't add them, they don't have any effect. The game overrides, even if you do not add it to your window, all these things are applied by default, as you can see. So you don't need to worry about this menu too much unless you need to go in and adjust something. One thing that you may want to change is that by default, we override your game mode. This is so that if your game is set up to do something like capture the flag, you may not want that in a movie render, probably. So we automatically override it with a game mode that just hides your pawn. But if you do need your game mode, then you can go in here and you can change which game mode we override it with to the one that you do want to use, and then that will work as expected. Okay, the UI renderer setting. This is an experimental setting that takes any UMG widgets that have been added to the player's viewport and renders them out to a separate layer in the output file. These are not composited into the final image like burn-ins, so they will always show up as a separate layer. If you're using EXRs, they'll be on another layer. If you're using JPEGs or PNGs, it'll be output as a separate file. Wave audio. So this is another experimental feature. You can export the in-game audio to a WAV file. This has some caveats that you should be aware of, though, is that audio that's not controlled by sequencer is going to have gaps between shots. And the reason for this is that when we render a movie and we do warm-up frames between shots, we're actually passing time in the in-game world. And so any audio that is being controlled by the in-game stuff, such as background audio, that will not get captured while we're doing those warm-up frames. So when you listen to it afterwards, you'll hear jumps between that. One of the other things to keep in mind is that even with media controlled by sequencer, it's not sample accurate. So you may have small hiccups between camera cuts when you listen to it afterwards. One thing that is new in 426 is that we no longer require running with the deterministic audio command line flag. In 425, you needed to use the deterministic audio flag, and that would allow you to use this feature. Unfortunate side effect of that is that you can no longer hear the audio because it changes to a different audio backend. So in 426, we've made it so that it automatically switches to the correct audio backend when you start Pi, and you no longer need to worry about that. Andy's going to go ahead and talk about the XML output for us.
Yeah, so we've added support for FCPXML Output. This allows you to export out your media out of Unreal in these Final Cut Pro XML format. It doesn't mean that it's necessarily for Final Cut Pro, but it's a standard that a lot of nonlinear editors use. What this does is it allows you to export your media into one kind of baked down movie file or separate image sequences, and then allows you to import that and that media and place it on the timeline in the same way you would see it inside a sequencer. So it holds all the timing information in terms of those cuts. And then you can rearrange those clips in different timing manners and send them back to Unreal, and it will re-import. It won't re-import the media, but it will re-import the timing of those clip changes. Some things to note is you have an idea of a time dilation track inside of Unreal, and we can respect that to a certain degree. It becomes a little bit more problematic when we're doing image sequences. So when we're slowing down time, a frame isn't necessarily 1 frame per frame anymore. So there's this idea of relative numbers that we can use and handle those. But in terms of the XML interchange between the two, it's a pretty good format. You can use it inside of like Adobe Premiere and many of the other NLEs to go back and forth, but it's not supported by every single NLE out there. So you'll have to, choose which ones, if that's the workflow for you. But a lot of times for the filmmaking audience, being able to go back and forth between the NLE and allow the editor to make some changes to the cut and then bring that back in is really important. So that's why we have added support for Final Cut Pro XML.
So one thing that we didn't talk about on the original output setting slide is the idea of handle frames. And handle frames are a way to automatically expand your shots by a specified number of frames. And one of the reasons you might use this is in combination with this XML is that you might render an extra half second before and after every shot. And then when you hand this over to your editor will be able to go in there and slide the shot around just a little bit if it makes the timing better between things. So that's a really useful thing. One thing to keep in mind, though, is that if you are using a time dilation track, importing that back into Sequencer doesn't work as expected, because once you've used time dilation, it's made sections longer than they actually are. So that's going to cause a lot of confusion in Sequencer. All right, so the deferred rendering option is probably the most common main option. This is going to produce the results that you see in the in-editor viewport, known as lit in the editor viewport. We've added a bunch of different features to this in 426, stencil layers, GBuffer data access, and alpha accumulation. These are all things that we're going to talk about in more detail later in this presentation. We've also added some settings here for disabling multi-sample effects and accumulating alpha. Accumulation of alpha is an advanced feature. It used to be part of the .png or .exr setting. That has been moved now to be part of the deferred rendering. Disabling the multi-sample effects is for certain render passes like ObjectID, where they don't support things like motion blur, temporal anti-aliasing, or depth of field. So we've added a quick checkbox here that you can enable, and that will just turn those off without you having to go through your project settings and your post-processing volumes and getting all those changed. One thing to know about using render passes in the movie render queue is that we render them all at the same time. And the reason we do this is that we're going to ensure that the content between all the render passes stays in sync, so you don't end up with issues where something happens slightly different the next time and your render pass is different. All right, so we have the high resolution feature. Andy is going to go ahead and give us an idea of some of the industries that use this.
Yeah, so for high resolution, we put this feature in with 425, and the purpose of this is to kind of get around the limitations of rendering on a single GPU. So it allows us to split up the render into multiple tiles that you can choose. So for example, if you had a 4x4 render, that would actually be 16 tiles, and that allows you to render at much higher resolution than what a single graphics card could do. So it gets around some of the limitations of VRAM and other things that we can't support fully just in the viewport. We've done some, and I know Matt has done some of like 32K images, so very large, high-res poster level for like automotive or architecture. This is a very common thing. And some of the things to note about it is there is a ability to kind of set an overlap region, which I think we'll show on the next slide, where you can put a blended region that allows you to take these tiles and take some of the screen spaced effects that we use to have more accurate results. So you can specify this blending region, which allows us to cover most of the render effects, but there are a few to just know and kind of be aware of is, TAA and auto exposure and screen space reflections and bloom and lens flare are not supported at this point. It's stuff that we're thinking about ways to look at into the future, but for the most part, many of the rendering effects that you would use in the normal renderer is supported. I don't know if there's anything else you want to kind of add on top of that, Matt, but
I think that covered most of it. TAA being not supported doesn't mean that you get no anti-aliasing. Instead, it just means that you need to use the spatial sample feature that we have in our anti-alias section, which we will talk about in a moment. Auto exposure, you'll want to use manual exposure in your cameras instead. For screen space reflections, you can actually use ray traced reflections, and those will work as expected. Convolution bloom and lens flares you could do in post-processing if needed. So even though we don't support quite all the rendering features, you are able to get most of these back in post-production. One thing I did want to call out specifically is that large render resolutions can consume a surprising amount of VRAM. Most consumer cards only have 8 to 12 gigs of VRAM. And when you use Unreal in 4K to make a 4K render, you're actually just spending 4 to 6 gigabytes of VRAM on the viewport alone. So you're now down to another 6 gigs for all of your model data, your texture data, and everything like that. So if you're having trouble running out of RAM trying to render out 4K images, this is a way that you can get around that by rendering out 4 1080p images for each one instead of one big 4K. It does allow you to create very large resolution images. The default maximum on GPUs is usually about 16K, and we've gone up to like 64,000 by 32,000 with this, so you can get really, really big images, although you may not quite need that many pixels. So this here is an example of how we do the rendering with the overlap. So again, we render in tiles. So for any given output screenshot or output frame, we'll render 1, 2, 3, 4 tiles. And you can see here visualizes the overlap region. And the reason we have an overlap region is things like depth of field. They'll come up with different answers on either side of the seam line because depth of field does a little guessing near the edge of your screen because there is no information outside the screen. So by doing this overlap and then fading between them, we can usually hide most of the effects. You can control this amount of overlap. Usually we start at about 20%, but depending on your content, you may need to go larger if you are seeing seams in that. So this here is a example of an image that we rendered at 32,000 by 17,000 pixels. This took only 7 minutes to render, which is pretty good for a 32,000 pixel wide image. And we can actually go and do a zoom in here. So this is the full image that we rendered. And if we wanted to do 100% crop of that image, this is what that looks like. So we've gone from this whole big image here, and just this one section of it still has this nice high quality. One thing you will need to keep in mind is that you do need relatively high resolution textures so that there's information available. If you don't have high resolution textures and you try and do a really big render, you're going to end up with blurry textures because the information is simply not available. Okay, so now we're going to talk about the anti-aliasing setting. The anti-aliasing setting is where we're going to control many of the new high-quality features that came in 425 mostly, but we have added some features in 426. Something that we should call out is that there's 2 different types of warm-up. What warm-up is that when we render a camera cut in Sequencer, oftentimes you need time to have passed before that camera starts actually capturing the output. And the reason for that is that things like anti-aliasing need time and to settle down into actually having anti-aliasing data. Cloth needs to settle. Particle systems need to run and spawn some particles. So we've put in the concept of a warm-up. The engine warm-up is going to it's going to run the game thread and not render anything. And this is going to work for most CPU-based effects. It'll let cloth settle. Particles that are done on the CPU will simulate, things like that. So those are pretty cheap to do, and you could just punch in 32 or 64 samples. The render warm-up ones are more expensive. For these, we actually render the whole image as expected, and then we just toss out the results before we don't save them to disk. So you want to keep those as low as possible because they do take quite a bit of time compared to the engine ones. But that option is there to get things like temporal anti-aliasing history. New in 426 is we have the use camera cut for warm-up option and render warm-up frames. And these two options are there to solve issues that people ran into in 425. Cloth, which we'll talk about in the troubleshooting section, especially benefits from using the camera cut from warm-up. And it's a way to actually evaluate the sequence leading up to the start of a shot. And the reason that you want to do that is if you have cloth and it is animating on a character, you may need the character to animate kind of from its reference pose. And once it's animated from its reference pose to your first frame, the cloth will be settled and everything will be good. Okay, next we're going to talk about subsampling. We have two different types of subsampling, which are controlled again by the anti-aliasing menu here. The two different types of subsampling are temporal samples and spatial samples. In general, you're going to prefer wanting to use more temporal samples. Spatial samples is really only there for short shutter angles. So if you're trying to make a really crisp image that has no motion blur, you're going to need to use spatial samples. But if you're using a trailer or movie, temporal samples is generally what you're going to want to use. So for temporal samples, we divide the time that the camera shutter is open into slices, and then we render out multiple frames and use engine motion blur to cover the gaps between them. What this means in practice is that you can get radial motion blur, or you can get nice arcs, which we'll show an example here in a second. If you're looking for a good starting point for boosting your output quality, 8 temporal samples is a good starting point, as pretty much the only setting that you might want to change. Our internal trailers use 8 temporal samples for, I think, 80% of the shots, 16 temporal samples for 15% of the shots, and then kind of some of the last 5% may go higher depending on exactly what's in that shot. So you don't need to go too crazy on this to start getting really significant returns on your investment. Benefits of using temporal samples is you're going to get better looking motion blur. You're going to get better looking anti-aliasing if you disable TAA. And you can get less noise in ray traced images simply because there is effectively more samples overall for the final frame. So radial motion blur, this is something that's very hard to do in real-time engines. Usually real-time engines use a linear blur, and that's only going to give you straight lines. And this can look really unappealing on rotating objects like car wheels. By using multiple temporal samples and combining several short linear blurs, the results are going to start to look like a smooth arc. So here in this slide here, this is an exaggerated example. This disk is spinning really, really, really fast. But you can see kind of how it's maybe not the best quality for the motion blur. It's going outside the object a lot. You're getting these really weird patterns where it's not like consistently blurring over the blurring into the next one. And so, while it's pretty good for games, it's maybe not something you want in your final output. By going up to just 2 temporal samples, we can see that the overshoot has been reduced drastically, and the overlap between colors is starting to get a lot better. It's a lot smoother and more consistent. By going up to 4 temporal samples, we're getting really close. 8 temporal samples is starting to look really, really good. You can see a little bit of banding between these, which you may not be able to see with the compression, but you can see as we add more samples, it's getting more and more detailed and accurate. And finally, for 16 temporal samples, this is pretty much a perfect radial motion blur. You're getting these really nice soft blends between each one, and it's staying inside the disk. So isolated test cases are nice to look at, but let's look at an example, a real use case example. The following images are from the Meerkat sample that we made in collaboration with our friends at Wet and Digital. This is available on the UE4 launcher. So if you want to download that, open up the sequence and do some renders of your own, you can do that. We just pulled it open, changed the anti-aliasing settings, and rendered out these images. So here's the default kind of runtime motion blur. Excuse me. You can see that there's some artifacting between the rear foot of the meerkat and the eggshell here. You're getting this weird blur where it's going outside the eggshell. And you can see that the meerkat body has a bunch of kind of just straight lines from the motion blur. And the tail itself is just a straight line as well. And again, that's because we do that linear motion blur. Here we've jumped up to 2. You can see that the artifact near the foot has resolved itself pretty well. You're starting to get a little bit more curve to these. This tail's starting to have a little bit of curve. We can do 4 temporal samples, 8 temporal samples, and up to 16 samples. One thing that is worth calling out is you can see that the difference between 8 here and 16 here is not really that significant. So you do have diminishing returns on more temporal samples to some extent. So you don't need to, always go crazy with your temporal sample count. This is, of course, going to depend on what your content is. The faster moving something is, the more adding temporal samples is going to remain effective. The other subsampling type we have is the spatial subsamples. Spatial subsamples jitter the camera, but don't allow time to pass between each sample. And this is really only used for when you have a 0-degree shutter angle and you want to create really crisp images. It will jitter the camera to give you anti-aliasing, but it doesn't pass any time in the world. So you're not going to get the benefits of that nice arc. And that's why we say that you should use, or you should prefer, temporal samples. One thing to keep in mind too is that spatial samples apply to each temporal sample. So if you were to just put in 8 spatial and 8 temporal, you're going to end up with 64 renders per output frame, which is probably a lot higher than you need to do. So spatial samples really are for when you have very short shutter angles. So you'll want to, again, prefer temporal ones as much as possible. All right, so next we're going to talk about saving and loading presets. Andy touched on this briefly earlier. We're just going to go into a little bit more detail about what the presets are and what they aren't, or how to save and load them. Okay, so there's 3 different types of preset assets. This is new in 426. You have queues, master configs, and shot configs. A master config is this top level one applied to the job in the top first column here under settings. Andy clicked on this earlier. And a master config is going to have some settings that can only exist there. So things like output, output file name, output resolution, those are only going to be available in master configs because they need to stay consistent throughout the entire render. Shot configs, on the other hand, allow you to override things on a shot. There we go. Half those slides out of order, unfortunately. So the shot configs are going to work very similar to master configs, but they can only be applied to an individual shot within a job. And so that's if you have, you want to override the anti-aliasing on a particular shot because you know that, hey, most of the trailer can be rendered in 8 samples, but this one looks better in 16. You can make a shot config that is 16, and you can apply it to the shot in the dropdown there. One thing to keep in mind is that if you add a setting to the list in the editor, so like we have on the left, it says anti-aliasing or output. If it is there in the editor, it will completely replace the one in the master. So we don't try and do any merging of like which settings you've changed. It just completely replaces it. So you do want to keep that in mind. Master configs we talked about earlier. Again, like shot configs, they replace everything. To actually save these presets is when you've opened up the editor, you have the pop-up window. You can go to the top right and choose the Save as Preset option. And that's going to save it to an asset on disk. You can check that in, and then your coworkers can share, and you can make sure everybody's using the same thing. Finally, we have the ability to save and load queues now. The queue option is available from the main menu. It works, again, very much like the presets do. Loading it will replace everything. You can save it out, you can share it. One thing about queues is that they capture the state of the queue exactly as it is. So if you've added a job, you've assigned a preset, you've modified a setting on that preset, you've gone down to a shot and you've done an override on that shot. When you save that as a queue, we're going to save it exactly as it is. So this is a quick way of, if you're trying to do, you're trying to repeat tests, you want to render a few frames, look at them, restart the engine after you've changed something in code or something, you can just click on Save Load Queue. Click it, it'll replace your queue like Andy showed earlier. You hit Render Local. It's a way to create very consistent results. All right, so scripting support. In 4.26, we've added a great deal of support for Python, blueprints, and then some more support for command line renders. So for the Python scripting, again, we're not going to go into the technical details too much because talking about code is not everybody's cup of tea. I just want to call out what we have available so that people can find more information on their own. So when we built the movie render queue, we designed this with Python in mind. So you actually have a lot of control from Python. One of the examples of this is you can actually control the behavior of the render local and render remote buttons on the main UI. And this can be useful for making an internal render farm where you override the render remote button to automatically send it to your render farm. And that way for your artists, it's nice. They just click the button. They don't need separate ways of submitting it or anything like that. So internally, we've done this. We've implemented a render farm. We use Python to submit the job from the user's editor to the render farm. And we use Python on the remote machines that they boot up Unreal. They start running Python code that we wrote. And then that talks to our render farm software to find out what job it's supposed to be working. There are some limitations to the Python scripting. Big one is it is editor only, does not work in shipping builds. Shipping builds are when you cook and deploy. So it's really for like final games. And so that's why Python does not work. One of the other ones is that you can't add new settings classes in Python. Python allows you to declare new UObject classes, but these cannot be saved. So you can't do this in Python where you make a new setting to be added to the list and then you add it to the list and then save it. Because Python classes can't be saved, that can't be done. So if you'd like to find out more information about our Python scripting, we have examples in the movie scene / movie render pipeline / content / Python folder. And with this, we ship 2 examples. One of them is an example in the editor, and it's going to show you how to create the movie pipeline, configure the settings, render it in the editor, change something in the editor world, and render again. This can be useful if you're trying to automate rendering turntables. You might want to assign your actor in the editor world, render the turntable, come back to the editor world, change which actor is in the turntable, render it again, and things like that. The movie pipeline example runtime executor, and this shows you how to define the behavior that is run when you launch it via the command line. Sorry about that. Okay, so command line renders. There's 3 different options that you can use when you're doing a command line render. One of them is that you launch it with a queue asset, which we have over here on the right. And you can see how simple this is that you specify your U project, you specify a map, you specify the path to the queue, and that's all you need to get all the settings that are in that queue. So that's generally like the easiest way is you just save out your project to a queue, and then you can just launch it with the command line just like that. Another one is that you can pass a level sequence and a master configuration. And that's if you have different level sequences that you want to render, with the same thing. And finally, the most advanced one is you make a custom executor and you have full control over what that does. And that's covered a little bit in the Python one before. So one thing is that we've removed the large array of command line arguments. In the previous sequencer render, we had command line arguments for most things, and you could configure the output resolution and the things like that. We've removed all those for the new movie render queue. They're still there for the old movie renderer, but they don't work in the new movie render queue. And the reason for this was that we have a lot of different options, and now that we have shot overrides, it would have gotten just really, really complicated to provide access to all of those on the command line. So we do have an example of how to use the command line. If you'll have to look in the source code under the movie render pipeline command line CPP file. And in the Python example from earlier, we actually show you how to read arguments off of the command line. So if you do have a workflow that does use the command line arguments from the old one, and you would like to keep that, the Python example will give you an idea of how you can kind of rebuild that on your own to listen to some of those command line arguments. Finally, we have runtime support now. So the basic features will work in the non-editor shipping builds. And this is useful if you build an application that lets people configure cars or visualization of some kind, and the end user is going to want to render out a nice movie. So we now support that to some extent. Some features like the ObjectID pass and the FCPXMLs do not work. Those are editor only. By default, you're going to get the same in-game widget as in the editor that shows you your progress through the sequence. So it's going to say, shot 1 of 5, things like that. This can actually be overridden with a custom widget, so you can retheme it to match your application if you wanted to put a nice UI on. So an overview of how you do this, and we'll have a screenshot in a second with an actual blueprint graph, is you create a queue, you allocate a job from the queue, and then you can configure the job, either by loading a preset asset or by modifying the config that's in the job. You're going to want to construct a movie pipeline in process executor, and then configure settings on the executor, bind any delegates you need, and then call execute. So here we have an example of what that blueprint graph looks like. You can see here on the left that we construct the queue, we save it, we allocate a new job, we set the sequence and the map to the ones that we wanted to use, and then we set the configuration. This can either be an asset, or you can call get configuration and edit it. We do have an example in the content folder of editing a configuration. So if you need more information on that, you can look in the plugins content folder in the editor. After you've configured it, you're going to construct an executor. You're going to configure it. This one says use the current level, so it doesn't reload your level. Bind any events you need, and finally you call execute. This will start the process. It will run until it's done, and then it will call the callback here, and then you can move on in your application. Okay, so next we're going to talk about some of the EXR improvements that we've made. One of the big things that we've done is that EXR image sequences can now write all the data into one EXR file. Before we would make an EXR, but we'd have one EXR per output type. And so that has all been combined into one file, which makes it much easier to pass around data because you just send somebody a single file instead of having to send 7 files and things like that. So when you render with burn-ins or an UI renderer, ObjectID, those are all going to go into separate layers in one file now. This can be disabled in the settings. Not all third-party software supports multi-layer EXRs, so you can disable it to go back to the old behavior. And there are third-party plugins available for common software that do add support for multi-layer EXRs, so you'll want to check that out for whatever software that you do use. One thing to keep in mind is that the burn-ins are kept as a separate layer and not composited together, and that's always true for EXRs. Additionally, this multi-layer EXR support only applies to the movie render queue's ability to write EXRs and does not apply to other parts of the engine that may load EXRs. So we've added some metadata support to the EXR, and Andy's going to tell you a little bit about that.
Yeah, so as Matt was mentioning, the EXR improvements have been updated quite a bit with 4.26. And so we're currently able to store a lot more of the metadata into the EXRs for various purposes. So you'll see things, and probably in a later demo, I can show some of that in the live demo, but you can gather the focal distance and focal length and sensor size and certain properties of the camera that you're rendering from. You can get like the author's name, the frame rate, and the level it was rendered. All of these are set up and render into the EXRs now, but we've actually also made the ability for you to extend that through C++ only, but I'll let Matt kind of get more into the details of that in just a second. But if you want to add custom pipeline scripting from your own, say, VFX studio, who would like to have some of the things standardized around your pipeline, it's pretty straightforward to add new metadata into those baked-in EXRs now.
Yep, and so as Andy mentioned, you can add your own C++. Really, you only need to override one function, and it's just going to be called every frame, and it's going to say what are the key values that you want to add to the EXR. So it's pretty straightforward to use. Again, we ship with a lot of default information. Particularly of interest is things like focal distance, focal length, and sensor size, and these are useful for some of the things that you can do in post-production. All right, so this is the last section on the first half, is we're going to be talking about troubleshooting. These are some common issues that we've seen people having in 425. A lot of them have easy fixes, so we just wanted to kind of go through them, let people know what those issues might be and how they could be fixed. So if you're seeing significant blurring when you start using temporal sampling, especially on the first frame, usually what that means is that if your first frame is blurred when you start using temporal sampling, is that you've actually sampled outside of the data range that sequencer has. And the next slide has a screenshot showing this. And what happens when you use temporal sampling is that instead of evaluating exactly frame 0 as you see in sequencer, we start evaluating a little bit before frame 0 and a little bit after frame 0. So if all of your data in sequencer starts on frame 0, what you end up happening is that first temporal sample evaluates nothing effectively, and then the second one evaluates what you expect, and your resulting image is two different images smashed together, and it looks really weird. So the fix for that is just to extend your data, especially the camera cut section. One other thing that you might see blurring on is animated meshes that have very motion blurred bones. You'll look in the editor and it'll be fine in the editor, but then you go and you render it out with temporal samples and suddenly their foot is really blurry and you're like, I don't understand why. Reason that this is caused is often by incorrect curves in your animation data. What can happen is sometimes the bones will rotate 360 degrees between frames. You can't see this in the editor because you have snapping on, so you're only looking at frame 0 and frame 1. But when we do temporal sampling, you start to actually see this evaluation where it goes through the 360-degree turn. To check this, you can just disable snapping in sequencer, scrub through the subframes, and you can see if your joints are doing any crazy motions. So this is an example of what your first frame might look like. You can see it's kind of two different images superimposed. They're very blurry. It's not clear what's going on. The fix again for this is you just go to your first frame in your sequence, make sure your camera cut track is extended, and make sure any other tracks extend at least one frame before. But some of the other features do use the extended camera cut as well. All right, so issues we've seen with the cloth. If your cloth is starting in the reference pose and then settling out over the first frame of your output, this just means that you need to add engine warm-up frames, and this will give the engine some time for the cloth to settle before we start rendering the output. One of the more complicated cloth things is that sometimes you can end up cloth on the wrong side of character joints. So especially with like cloaks or capes, and this is caused by when we evaluate the first frame of the animation, we actually teleport the bones to the final position for that animation. Excuse me. And if the bone position is too different than the reference pose, it effectively clips through the cloth, and then the cloth can't resolve it to end up on the right side. And so the fix for this is that you can use the new Use Camera Cut for Warm-Up feature. What you're going to do, as you can see down here in this sequence here, is you can extend out your camera cut section, and you're also going to want to extend out your animation data. And usually what you do is that on frame, this is -96 here, your character would start in the reference pose, which would match where the cloth simulation starts. And then you're going to have your character animate into the first frame that you actually want in your output. And when you use the Use Camera Cut for Warm-Up, this is going to actually make it evaluate frame -96, 95, 94, and so on. And so what this does is it effectively slowly brings the character into position, and that's going to keep the cloth on the right side of their bones. Particle system issues. If you're seeing the particle system doesn't warm up and it seems to be just starting on the first frame, you probably need to use render warm-up frames. Some particle systems features like GPU simulations don't work unless you actually render them. So by using the render warm-up frames, then the engine warm-up frames are going to get rendered and discarded. So that's just a quick way to fix those. If you're seeing particle trails that are bunched up, or they're not following the characters from the previous shot, you need to use the same trick as cloth, where the animation data extends before the sequence, before the shot starts, and then check the use camera cut for warm-up. And that's going to, again, evaluate each of those poses, and that's going to give a chance for the particles to be, trailing behind the character. If you're seeing significantly different results when using temporal samples, life cycle tracks in Niagara combined with some of the desired age modes lock the update rate to the sequence playback rate. When we do temporal subsampling, the sequence playback rate is still 24 or 30. But if you're doing 8 subsamples, you get 24 times 96-ish higher resolution. So you may need to play with that setting in your Niagara particle systems. You may see different results when you do simulations. And this is because when you're doing it in the editor in the game, each frame is about, 1/60th or 1/30th long. But when we start doing the temporal subsampling, it starts being, even smaller, like 2 or 4 milliseconds. And so this is going to give you a lot more resolution in your actual simulation. So your simulation results may be different. So unfortunately, in the way you do this one is you just need to test your particle systems early. Looks like we lost Andy there. He'll be back in a second. You're going to test your particle systems early with temporal sampling. Try and decide on temporal sample count early on, and author your particle systems by rendering out the shots with the specified temporal sample counts. It's not a great workflow right now. It's something that we're looking to improve, but that's how you can work around it in the meantime. All right, so here are some common pitfalls that we see. If you have a large number of elements that are missing in your renders compared to the editor, this is usually because you have a sublevel that's set to blueprint streaming. And so when you see it in the editor, because that's how the editor works, but then when you load the game, because it is set to blueprint streaming, it doesn't load. So therefore, it just suddenly is missing. And you can either convert this to an always loaded sublevel, or you can use the level visibility track and sequencer to animate the visibility on. If you see that sequencer is failing to animate some properties like the lighting or some values on some characters, it's often that there's gameplay code that is fighting with sequencer. So sequencer will evaluate a value, and then there's some gameplay code that you've written that is trying to reassign that value. And so it ends up looking like sequencer is just not animating some of those properties. So you'll need to go in and you'll need to look at your gameplay code and see if there is something there. If you see that your camera's in the wrong location or not animating, often that's caused by not having a camera cut track. Sometimes people end up in situations where they've added an animated camera and sequencer, and they've looked through the camera and sequencer and they say, hey, this looks great. When they go to render, it then doesn't use that camera. And the reason for that is that you need to use the camera cut track and the camera cut section to tell sequencer which camera specifically to look through, because you can have situations where there are more than one cinematic camera in a shot, and instead of guessing, sequencer is going to rely on this camera cut track. So when you're in doubt about if it's a movie render queue issue, one of the best ways to test that is just to do a normal play and editor session. Movie render queue just uses the play and editor feature under the hood. So you can add a level sequence actor to your level. You can set autoplay on, and then choose play and editor from viewport. If what you see in Pi is different than what you're seeing in the editor, this means that you likely have the game code that is fighting with sequencer. And so you're going to want to get those resolved before you try doing a movie render queue render, because it's going to have the same problem. You'll also want to check the output log window. This is available through the window dropdown, developer tools, and then output log. That often contains more information than what gets shown in the UI. So if something's looking kind of weird, skim through that and see if there's any warnings printed about, what's going on. If you're using the new alpha channel functionality, which is an advanced feature for part of Stencil Layers, if you don't see any alpha in the output, you need to make sure that you've checked the accumulate alpha checkbox. You need to make sure that the project setting is set, There is a project setting. It's covered in the documentation, and the UI will try and warn you if that project setting is not set. Currently, screen percentage does not support passing the alpha channel through, so you will need to disable screen percentage on the shots that you want to use this alpha channel on. And what you can do instead is just increase your base output resolution and then resize it back down in post. The screen percentage is just doing that under the hood. Because if you have a 1080p image with 200% screen resolution, it's really just rendering a 4K image and resizing it. So you'll get very similar output doing this. If you're using post-process materials to change the look of your scene, then it's important to be aware that there's some changed functionality in the movie render queue. If your post-process material is set to the after tone mapper domain, then your input data is different than you expect. So when you use the viewport in viewport in the editor, and when you use the old sequencer render, the incoming data to the post-processing material is actually already in sRGB space. But when you do it with movie render queue, excuse me, the movie render queue is always going to provide the data in linear space, even if we later apply an sRGB curve. So what this means in practice is that when you see it in the viewport, it's in sRGB space. You've done that. When you do it in movie render queue, it does come out to the post-processing material in linear space. So as a workaround for that is the material graph provides nodes for converting between sRGB and linear and vice versa. And then you can use a console command to trigger a custom event to swap the post-processing material. And that way you can automatically handle both cases. Miscellaneous category errors. So new in 426 is that if there is an error during movie rendering, we will try and print it to the message log and pop it up after the movie ends. Important warnings and errors are going to go into this new high quality media export category. This can sometimes not be the default category, even if you do have errors. If you have a blueprint error that makes a runtime error like a null reference exception, that's going to make this message log look at a different page by default. So you do need to skim this and make sure that there's nothing in the high quality media export. If you don't have any other errors, this will be the default tab. One error that you might see quite often is that, or occasionally, is that you have too many temporal samples for a given shutter angle / tick rate combination. And this is saying that you've got too many temporal samples for your shutter angle. So if you have a 0-degree shutter angle and you try and use temporal samples, you'll start to see this error. The fix for this is either use a longer shutter angle or consider using spatial samples. If you're using the queue and you have jobs with different maps on them, this can occasionally lead to crashes. We've seen crashes caused by running console commands from construction scripts and actors. When you run a console command, there can be unexpected side effects. So if you are seeing crashes when you're loading the different map, you can try looking to see if you have any of that. Miscellaneous continued. Media track playback speed. This one comes up pretty often where people will render out a movie and then any media sources within the engine are playing back very quickly. And this is caused by if sequencer doesn't control the media source, then it's using effectively the wall clock time. So because more time is passing IRL than in the actual engine, it gets out of sync. The way to fix that is that you can use image sequences as your media type, and then you can control that media source in sequencer, and sequencer will try and backtrack to the correct time for every frame. If you're getting GPU crashes, these are unfortunately a little hard to debug, as they can be kind of different types of crashes, and also you can kind of get weird error messages because handling this stuff is very hard. Often it's either an out-of-memory crash or you're getting a TDR event from Windows. TDR is that your graphics card took too long to execute something, and Windows thinks the driver has crashed, so it shuts down the graphics card driver for you and it reboots it. This is great when it does actually crash because it keeps your computer from blue screening. The downside of this is that it crashes the engine and you are left with no render. So you can try and see if it's an out of memory issue by looking in the task manager and looking at the dedicated GPU memory slot. If it gets close to your limit there, you see here we have 5.3 out of 48, not really close. If you start getting close, you're kind of in the danger zone. It's not necessarily a super accurate moment-to-moment display. So if it's 11 gigs out of 12 and it starts crashing, that might be an out-of-memory thing. One thing to keep in mind is that some hardware configurations will use virtual memory automatically. It'll say, hey, you're out of GPU memory. We're going to use some of your system RAM to hold your data. While this is good for not running out of memory, it's unfortunately very, very slow. So your renders will suddenly start taking like hours instead of minutes. And it's not really ideal. So you'll want to keep an eye on that. If you do need to get some of your memory back, you can try disabling some of the extra index buffers in project settings. We store depth-only index buffers and reverse index buffers, which give you some performance benefits, but they also cost memory. And you can use the command rhi dump memory to show an approximate breakdown of where your VRAM is going. If you're using really large images, or really high quality settings in the ray tracing, it could be a TDR event. And you can extend the TDR delay in the Windows registry so that Windows doesn't kill it for you. All right, so that mostly wraps up on the first section. I need to step away for just a moment. Victor, I will turn this over to you, and maybe there's some questions Andy can answer while I'm out.
Sounds good. Yeah, we received a couple in regards to file format exports, and Andy, I think you can tackle some of these. GameSuki Studios asked, will you ever do MP4 file formats for render?
Yeah, we're looking into adding additional file formats. As you can tell from this release, like some of the focus on 425 was getting the core infrastructure switched over to allow for a lot more advanced rendering features. 426 was enabling a lot more of the image sequences support, the Pro codecs back, but we're definitely looking at kind of the next tier of things as more of the streaming codecs and the web codecs and the kind of things that people would like to use in the future. So it's stuff Matt and I are trying to evaluate and put together as far as order of priorities. So yeah.
Bob's Not Your Uncle followed up with, is it possible to do this using C++ if one is not very C++ savvy? Are there any resources one could follow to make this a feature in the engine before we support it officially?
Do you mean for added codec support?
To export as MP4.
Yeah. It depends. You could write your own, each kind of codec. If you look like the Apple ProRes and the DNx are separate codecs. So if you looked at those as examples, then you could definitely use those as a basis for writing your own codec export plugin. And then you could tie it in the same way. You can look at the example of like what we've done for ProRes and those as others to swap that in. So it's possible, yeah.
Poco 3D asked, what is the best format for using animated textures?
Sure, animated textures. I guess in terms of something that's in the 3D scene, as Matt was saying, is probably your image sequences. So the image sequences at this point are frame accurate. And so as we tick each frame and sequencer, then we'll pull that exact frame, and those are frame accurate. If you're using, as you mentioned, like movie files and some of the other things, like more time has passed between the render. That is something we're honestly looking into right now with the media framework team, is trying to get a fix in for this release. And I know they have some code checked in currently for us to look at in terms of updating some of the frame accuracy. That's kind of one of the number one issues I would say people tend to ping us about is, hey, why is my video playing faster than usual? So I would lean towards image sequences for this release, but hopefully we can have something in there in a future release that fixes those.
Just
Robbie,
interjecting here that I have returned, although I didn't catch that question. So
welcome back, Matt. Rob asked, is ProRes with alpha supported?
Yes. So you do need to turn on in the project settings. You need to turn on to allow the alpha channel through post-processing. So just search alpha in the project settings, and you'll see that does have to be enabled. And you do need a blank spot in your scene that has no sky sphere, that kind of thing, so that it actually will show through. That's one of the kind of gotchas that I've seen many users kind of fall into so far. Is they might have something like that that's covering the screen. So just if you have those two, then yes, we can support the alpha.
Just want to add on to that one is that not all ProRes codecs support the alpha channel, so make sure you check the Apple documentation and choose a codec that does support the alpha channel.
Yeah. And I think out of the box, it's the 444 and the XQ, which are, they're heavier codecs, but for professional users are kind of used to that. But yeah, as Matt said, not every single flavor of ProRes does alpha.
Let's see. Yuris999 asked, is there a way to synchronize sequence playback time with blueprints? For example, syncing up a media playback asset with the current frame of the playback.
I can work on this one. The short answer is it's not super simple. One thing that you could do that might be the easiest way to do that is to pull your blueprint into Sequencer and make a integer property on the blueprint itself, and then key that integer property in Sequencer. At frame 0, have its value be 0. At frame 1, have its value be 1. And that's going to increment every frame if you use the post-interpolation settings as a linear, or you can just go to frame 50 and put its value as 50. So that'll make it so that the property in the blueprint is being animated each frame, and then you can try and read that property in your code in tick and do something to respond to that. You do need to take in mind that temporal subsampling, the integer is going to still stay as a whole integer. So you'll need to consider if you need to do something different with that, and you may need to use something like a float and then do something with the subframe data.
I'm going to butcher this username, but Newshishun asked, is it possible to add a post-output console command to run a video compression tool like FFmpeg on the frames after render?
You could use the console command, or actually you cannot use the console command section, unfortunately, because what happens is that we run those stop console commands or in console commands, I forget which we call it. We run those before we finish writing all the frames to disk. And so that's actually going to be a problem if you're trying to do something with all the frames on disk. You have two options. One is you could do that and just use an arbitrary delay of like a second. Actually, that won't work because it'll shut down on you. The best way to do it is to use Python and use our Python scripting example for the editor. And you're going to have the Python read the UI, the user interface, and launch a render. And you can use the post render finish callback in Python, and that will be called after the render has finished, written all the files to disk, and closed the editor or closed the Py session. So that's going to give you the most reliable way. Is just listen for the executor finished event from Python. You unfortunately do just need to script starting the thing from Python as well, but we do have an example of that.
Elfiant asked, when I'm rendering a shot with tone mapper disabled, what is the color space that I'm getting? It doesn't seem to be standard linear gamut. And how do I render footage with linear color? Thanks.
So that one's a complicated question, or the specific details are complicated. We do talk about it a little bit more later in the second half. One thing to know is that when you disable the tone curve in Unreal, we are in linear sRGB gamut. But there is no precise way to recreate the Unreal look from that linear output. We apply a tone curve, and that tone curve doesn't line up necessarily with any other color space. So this is something that you might want to use OCIO to do in the future, is converting that the Unreal space, which is linear sRGB, into whatever your expected one is, and that way you can reapply that in post-processing and get the same result as you see in the viewport editor.
See, IO Matthew asked, is it possible to automatically replace all the real-time sequence with the rendered ones?
Currently, we don't have any functionality for that. I think what the user is asking is that you render out a movie, and then in Sequencer, you, instead of having the real-time content, you had a media player with that. It's not something we currently support. You could probably put it together with Python if you wanted to. You can manipulate sequences in Python in the editor. But there's some extra setup of like, you have to get the media track, and you have to get it on screen somehow. So it's not something we currently support.
Yeah, not out of the box at this point.
Prime Gaming Alex Goss asked, if I want all of the effects that the tile output does not support, should we be able to expect to render non-tiled output 4K frames outside of real time?
This is going to depend on your graphics card and your TDR settings. Again, the tiled output is mostly a workaround for large resolutions. So there is no card on the market that will let you do greater than a 16K texture. So if you need greater than 16K, you have to use the tiled renderer. But the GBuffer becomes really, really expensive memory-wise, and things start to take really long. So as we said earlier in the presentation, at 4K, the GBuffer is 4 to 6 gigs, depending on which features you're using. So if you went up from 4K to 8K, it would be like 16 gigs of VRAM. So yes, as long as you have the memory and you set the TDR high enough, you should be able to do that. It's really just there as a workaround for people with lower memory cards or TDR issues.
Yeah, I would say like 4K seems pretty safe if you're on a recent new machine, in the last couple of years. But if you're on a very old hardware, then that might be an issue. If you're getting into that 8K realm, that's where Matt was kind of saying, like that's where the tiling render kind of starts to come in at those high resolutions.
Y'all good to continue for a bit before we step into part 2? Cool. We got plenty of good questions here. Scott VR asked, ability to output depth map in 32-bit EXR, is it possible?
In 426.1, which is not quite released, it will be possible, and we will be talking about that later.
Soon TM. Let's see. Master Chief UA asked, when rendering with movie render queue in 426, grass type static mesh, parentheses, static mesh scatter on a landscape, is scattered on the whole landscape regardless of your settings, such as max distance to draw, and takes only LOD 0. How can this be undone? Rendering using sequencer does as expected.
So I think we do some, we try to apply some of those higher quality settings, like I said, in the game overrides setting. Probably what you're going to want to do is you're going to want to add the game override setting to your job, and then turn things off and see which one you turn off fixes it. And then if it might be the LOD 01, excuse me, which tries to turn off like skeletal mesh LODs, particle LODs, static mesh LODs. So if you turn that off, then you can look in the source code to find out which other things it's normally turning on. And then you can use the console variables to kind of turn the other ones back on that you still do need. And if that doesn't do it, then you should submit a bug report with an example that we can reproduce.
Vandal Savage asked, do we have the option to render out motion vector paths?
Yes, and we'll be talking about that next.
We'll cover that. Yeah, we'll be covering that in just a minute. So,
right, only a few more, and then we can move on. Burn Saga asked, I think this was referring to the portion when you were talking about exporting during runtime. So this can be used at runtime and used, for example, for a player to export high-quality gameplay footage? ?
Yes and no. It can be used in shipping builds, like we said. Writing images to disk in real time is like rendering and writing to disk in real time is complicated, and most computers are not able to do that at real-time frame rates.
Yeah.
So it's really actually the writing to disk part is usually the slowest part. I know we can do like 720p bitmap files to disk at like 40 frames a second. But you're probably going to want to look into a different solution that does some sort of hardware encoding on the GPU or something like that, so that you can do footage like that. If you're trying to do, if you've recorded the player's actions and you have a way of playing it back in your game and you don't need it to be real time, then you probably could do that.
Yeah, at this point, we're kind of targeting maybe a little more of the enterprise customers who might be building something like a car configurator, and they want to be able to customize, some of the abilities of the car and that kind of thing, and then render out that as a movie file to be able to take away those kinds of things where you might not be impacted by the gameplay at that point, and you're okay with sitting and letting it render for just a minute or two, is kind of the first target for some of those in-game experiences.
Carlo Alt asked, the particles freeze after 130 frames with very high temporal sample count values, parentheses 16, 32, etc. Render warmup, engine warmup, 32, 64, 128, and he's on a RTX 3090. Is this a solvable problem?
This one might be related to, jump back in the slides real quick, actually. There we go, that slide. This one might be related to the lifecycle track, if this is the Niagara particle system. So try not using the lifecycle track and try changing the desired age mode to be, I think it's tick is the one you want. You'd have to look at the descriptions. The one that does lock the update rate to the sequence playback rate, you're not going to want. So unfortunately, I think the answer is you're going to have to play with the particle systems settings and see if you can get something that works right now.
As Begun asked, can I render to GIF format?
That is not currently supported, but you can write new outputs as a plugin for the movie render queue. So you can declare your own output format, and you'll get a callback that says, here's all the image data for the frame. And then it's up to you to decide what you want to do with that. So that is something you could add on your own without modifying the engine.
Rebecca Cedermalm asked, when it comes to the ObjectID pass, will you add support for multi-sample effects as well?
So this is something that we would like to look into in the future. Unfortunately, it's a very complicated problem. And what we have is some workarounds for creating some of those multi-sample effects in post-production. And that's what we're going to go into the second half. So even though it doesn't support TAA and depth of field, you can get some of that back, and we will be talking about that.
Two more, and then we can continue. Scott VR asked, do you have a suggested amount of warm-up frames?
For render warmups, we start at, I think, 32. That's usually enough just to get TAA, to get nice anti-aliasing. You could go higher to 64, 128. Engine warmup frames, 64, 100. It really depends on your content. And we just pick low defaults because it's faster. And some people have really expensive content that don't need the warmup frames. So that's why we don't have it on by default. So I would say within the 100 frame range, because that's, if you're playing the game at 30 FPS, 100 frames would be about 3 seconds of gameplay history. So.
And with that, Matt, you're not paying the penalty of like re-rendering those frames, right? So the cost is less of just warming them up versus actually like rendering handles, for example.
So if you're using the engine warmup frames, yes, they are cheaper because we don't render unless you've turned on the setting to render them. And one other thing that I thought of is that one thing you do want to be careful with the render warmup frames is if you set it to like 300, it's going to submit 300 renders to the GPU on that final frame. And that doesn't crash the GPU because it's working through them one by one, but it's going to cause this really long stall because it's trying to do all 300 of them at once. So if you're getting into that case, I would suggest using kind of that excess camera cut stuff combined with render warm-up frames, and then using a low render warm-up count and just using the engine warm-ups that are being rendered.
Then another question from Vandal Savage. When can we expect support for video input inside Sequencer?
I think maybe he's talking about there is support now for media tracks, which we can have a media player that allows you to play. And so if you have a plane in the scene with a video on it, you can control and scrub and play that back currently now, and you can do that with image sequences as well. I'm not sure exactly if that answers the question or not, but
if you want to follow up, Vandal, please go ahead and do so. Those are all the questions for now. We can continue if y'all want to.
Cool. I am going to grab some more water real quick. I just didn't want to miss any questions, so that'll take me 1 minute, and then we'll get going. Perfect time for everybody watching. Go grab some more water as well.
Listen to Matt, y'all. It's important. We don't have the UE4 bot active at the moment, but otherwise you could tell us to drink water. Were you going to say something, Andy? Oh, water? Yeah.
Yeah. I can talk a little bit if we want to get going. I could do the next slide for Matt, just on some of the passes, although he needs to advance it. So
I have returned. Benefit of small houses. Kitchen's not very far away. All right, so we're getting into the more advanced kind of post-processing workflows now. This stuff is all pretty complicated. Some of it may not make sense if you're not familiar with the how these things typically work, but we're going to try and do our best to make this approachable to everyone. So the first one we're going to talk about is the ObjectID render path. So what is an ObjectID render pass? In Unreal, which is a little bit different, and we'll talk about it, we render a unique ID, which you can see visualized here on the right as colors. Unique ID for every component in the world. So a static mesh actor has one static mesh component, and that will give you one ID. You can have actors with multiple components, and those will give you multiple IDs. When we render this ObjectID format, we output it in the Cryptomatte standard. This is an open source standard that there's some plugins for. And that's the one that we choose to output in. We do not support post-processing, as we mentioned briefly earlier. So no TAA, no depth of field, no motion blur. And temporal samples physically works, but it does not produce expected results because the math is not correct. And we'll talk about, again, that a little bit in a little bit. And this is an experimental feature. So as an overview of the ObjectID pass, it's going to require using the EXR sequence output type. It doesn't work with JPEG because they don't have, they only store 8 bits, and Cryptomatte needs 32-bit. We, again, output in the Cryptomatte standard. Plugins are going to be available for common third-party software. Nuke has it. Andy, do you know of any other software? I know there's there, I just don't know the...
There's extras for Photoshop and After Effects, inside Fusion, and several others. But Cryptomatte is standard. Even like Blender has picked up now, and most of the offline renderers, such as V-Ray, Arnold, Houdini, all of them support it. So there's quite a bit of industry support around this format, Cryptomatte, currently.
Okay. So one thing that if you're used to using Cryptomatte in other engines or other software, obviously, as we mentioned, no post-processing support. So that's going to be kind of different. We only support grouping per component. It's a static mesh component, but it really means every component. So that means you can't get a per material or a per namespace ID as you may be able to in other software. Instead, you'll get like static mesh 0, which is your TV, wall 1, which is your wall, things like that. Performance is, the accumulation is somewhat performance intensive. I think you typically don't notice this as much in offline renderers because the rendering takes a long time. Here, rendering is actually faster than accumulating the results. For 426.1, which again is not out yet, we have improved the performance substantially, and it should be much more usable. It's about 10x faster in most cases, so that can get you down to about half a second per frame for a 1080p image, which is pretty reasonable. As we said earlier, again, no post-processing support. The reason we don't support it is that these post-processing operations happen on the GPU, and they're blending multiple pixels together as colors. So, red plus blue makes, I don't know my color wheel.
Purple.
Yellow. Purple. So that's how all the post-processing effects work. If you try to blend object IDs, it would not produce the same results because while we render them as colors, they actually have specific meaning. And when you blur those colors together, it produces a different meaning that's no longer valid. But you can rebuild anti-aliasing, depth of field, and motion blur in Nuke if you use spatial samples from the anti-aliasing section. That's going to produce an anti-aliasing pattern that does work with the cryptomat. So you do get nicely anti-aliased edges. You can write out the depth and motion vector textures. And then you can use these textures to create depth of field and motion blur in post-production software. And we will be showing you a little bit of how to do that. All right, so for the setup of using object IDs are kind of a few steps. So the first one is you're going to need to use the movie render queue additional render passes plugin. Once you have that enabled and you've restarted the editor, the object IDs one, as you can see here, will show up in the dropdown for plus setting. When you are doing this, you'll need to go to the deferred rendering and check the disable multi-sample effects. And this is just going to automatically turn off things that blur the pixels together for you. It's just a handy checkbox so that you don't have to go into project settings, processing volumes, because you might want to render once without object ID and once with it. So that checkbox is there. Under the additional post-processing materials, you're going to want to expand that array and check enable on both of them. We have 2 there by default, and we'll talk about them a little bit more later. The 2 that are there by default are world depth and motion vector, so you really just need to hit enable on them. After you've done that, you're going to add the object ID setting to the config. Then you're going to want to go into the anti-aliasing and set 8 or more spatial samples to overcome the lack of support for TAA. You could do more than 8. 8 is a good starting point for having nice looking anti-aliasing. As we mentioned earlier, temporal samples, while it will technically render them, it's not going to give you what you expect. Because we've disabled the motion blur, the final image that comes out of Unreal is going to have kind of like stamped ghost copies of everything, and there's going to be no blur covering between them. So it's going to end up with a look that you don't expect. And then when you try and blur them in post-production using motion vectors, it's blurring data that's not blended together correctly, so you end up with the wrong look. You are going to want to disable the tone curve if you're doing depth of field in post to get the really bright bokeh highlights from the depth of field. You do need to be in linear space, so disabling that when you export will give you the bright highlights that you see in Unreal. One other thing that you might consider is disabling screen percentage. Screen percentage will cause the pixels of your RGBA image to not quite line up because it is, say a 2:1 resize. So you're going to want to go ahead and disable that. We don't do it automatically because some people will like that effect, but really we recommend disabling that and using a higher output resolution if you need. All right, so what does what does an ObjectID EXR output file look like? Again, this requires multi-layer EXR files. It does not work with single layer ones. This is a requirement of the CryptoMat standard. You're going to have the world depth channel in that EXR file. The depth in world units, which is centimeters, is going to be stored in the red channel on the world depth texture. For the motion vector channel, you're going to have velocity normalized to the screen, stored in red and green channels in that. You'll see actor layer 00, 01, and 02. These are the CryptoMat binary data. You can look at them, but they're not meant for human consumption. You just use the CryptoMat plugin, and that'll make sense of them. And then finally, you'll have your base RGBA, which is going to have your scene with anti-aliasing, but no depth of field or motion blur. So here's the final image RGB from a CryptoMat or ObjectID render. Apologies. As you can see, there's no depth of field, there's no blurring, but you do get nicely anti-aliased edges. This is what the depth map might look like. Apologize. We have done we've rescaled it to be displayable on a normal screen. Usually it's in centimeters. This would be the motion vector. Again, we modified it for display so that it can show up. And finally, this is what the output would look like from the ObjectID pass visualized by the Cryptomat node in Nuke. You can see that each object has a different color. All right, so the world depth pass. And somebody had asked about this in 32-bit earlier. How to get 32-bit, we'll talk about later in the presentation. But when you do render the world depth pass, the world depth in centimeters is stored in the red channel. The world Z height is stored in the blue channel. This is not required for ObjectID workflows, but it is useful for some people to have the Z height of every pixel. The depth map does only store the depth for opaque objects, so translucent objects are going to not show up in the depth map. When you use spatial samples, you're going to actually end up creating an anti-alias depth buffer because you render the depth buffer for each sample, and then we average those together. It's not technically correct, but it does appear to work in both cases. It's something that we're hoping to be able to improve sometime in the future, is giving you a little bit more control over how some of these passes get added up. For the world depth pass, focal distance can actually be driven by EXR metadata to automatically match the in-engine depth of field. So here on the right, the blue field and Nuke are saying that there's a code expression driving them. We've pulled the focus plane from the EXR metadata. We've calculated the size of the depth of field from the metadata in the EXR. And we've pulled the number of blades in the aperture also from the metadata. And so that's going to allow you to get much closer results to what you see in Unreal. And you don't have to export it separately and key it and keep track of it. It's just in the EXR automatically. We do provide an example of how to do this in the online documentation. For the motion vectors pass, we store the motion vectors in 0 to 1 space, which means that 0.5 is no motion. So that's why you get like kind of a yellow color for most of it. So 0.5, 0.5 means there's no motion. The red and green store X and Y screen space velocity. This can differ from some post-production, offline renderers, that we store ours in screen space. What this means is that you may need to shuffle the channels around for some software to get this to work correctly. In Nuke, I had to take our red-green channels and swap them to be green-red. Is what you can see going on over here. It's just a shuffle node to swap them around. One other thing to be aware of in the motion vector pass is that X and Y store different magnitudes. And the reason for this is that because we've normalized to the screen resolution to be 0 to 1, if your image is wider than it is tall, then the same 0.1 has more distance on the wide axis than the top one. And depending on which software you use, it may not want that. So you can actually multiply the channel by the aspect ratio. So if you do 1080 divided by 1920 or 1920, yeah, I think it's that one. Divide width and height, and you'll end up with 0.5625 for 1080p image. So what you'll do is you can subtract 0.5 from the red channel, so that it's now at 0. Multiply it by the 0.5625, and then add 0.5 back as it expects it to be with 0.5 in this center. At least for Nuke, the amount of strength on the vector blur we needed to set to multiply it by the largest image dimension. So for a 1080p image, we had to set the strength to 1920. When you do vector blurs for motion blur, it does need to be applied after depth of field. So putting it all together, and Andy's going to show this off in a little bit more detail, actually using it in Nuke, but how do we use this ObjectID pass to make changes to our scene? So you're going to use the Cryptomat data to create masks to select objects in the scene, and that's going to line up with the pixels from the RGBA channel because we turned off all this post-processing effects. So when you pick a couch from the scene in your Cryptomat, it's going to line up pixel perfect with the RGBA image. You're going to apply color correction or modifications to your RGBA channels based on this mask generated by Cryptomat. Then you can apply depth of field using the world depth architecture while automatically extracting the focal length, sensor size, etc. from the metadata. Then you can apply motion blur using the motion vector data. The final results is going to have similar motion blur depth of field to Unreal, but it's not going to be a perfect match because, again, it's two different software with different algorithms, but you can get a pretty close look between the two different ones. For these operations, you generally, again, want to be in linear space, which is linear sRGB. So that means disabling the tone curve. When you do these masks, even though they are pixel perfect, if you do extreme color correction to something, you can end up with a little bit of a visible halo. That's kind of the wrong color. It still has some of the original color. And this is because we only store the final color for a pixel. And when we go to modify the pixel, we actually don't know that, so say you have a couch and the background on the same pixel. You can pick the couch with Cryptomatte and you know that it has a weight of 0.5. But when you change the original color, some of that original couch color and some of that original background color, and then stay there. Apologize for the honking in the background if you heard that. So if you do extreme color correction, you may see some haloing, but for light editing, it works pretty well for most cases. But if you do see haloing, it may be because of that. So this is a example in Nuke of what that looks like put together. So you have the two Cryptomatte images. They're used as masks for the hue shift. You take that, you feed it into the Z defocus node for depth of field. You do the math we have to do on the motion vectors to get them correct, and then you do the vector blur. So this is an example of the image, final image RGB as it was in Unreal, or as it was in the texture. And here's an example with the depth of field applied, and we've done some hue shifting using the Cryptomatte as masks. So you can see that we've made the fan blades green, we've made the floor purple. I unfortunately am not a very good artist, but this is giving you an idea. You can do these kind of post-production shifts in post, and it does work correctly with blurring. As you can see here, the fan blades are a little out of focus, and the blur has the correct grain colors. It doesn't have kind of part original, part new stuff. All right, so Andy's going to go ahead and give a demo. I'm going to step away real quick while he does that demo, but he's going to go ahead and show you how to actually use that in practice in Nuke and kind of show you the power of it.
Thanks a bunch, Matt.
Cool. Thanks, Matt. So yeah, I'm going to walk through some of the things that Matt had mentioned and just show you some of the basics of some of those features more live, I guess, in a informal way. So as Matt had mentioned, we have a comp setup here. We have the Cryptomatte nodes, and see here that we have our object IDs. When I double click on the Cryptomatte node, you can see I have this add picker and remove picker. So I can add and remove any of these by holding control and just clicking. And now you can see if I inspect the alpha channel, that these have been added to that mask. So I've went ahead and did a couple of those here in this example. If I take a look at this one, I've selected the back wall. So if you look at the alpha channel, you can see this guy here. And then the same, I have a third mask that's just for some of these foreground, I think that's called a Newton's cradle object that I'm going to do some color corrections to, as Matt was showing. So inside of that, if I look at the hue shift here and I turn this on and off, you can see the two objects that I have selected now are getting the color correction. So if I turn that back on and let's pick something different. So if I view the Cryptomatte node, add to the picker, and we'll pick just a couple more items. Scene. Inspect the alpha, looks good. And see here, now you can see all of those have been shifted to more of a blue hue. It allows you to target specific actors in the scene that you want to change and manipulate in an easy way. So in a similar way, I have some color correction applied to the back wall here. Toggle that on and off using that mask. And as Matt was saying, if we step further down the tree, now I have this Newton's cradles changed as well with a similar mask. And we can pipe that into this defocus node. So if I preview that node, you can see here that we're using, and Matt had mentioned, it's the world depth channel. I popped this open. Sorry for the large screen resolution. I don't know if you can see it, but it's the world depth here is what I'm using. And with that, we have an expression tied to the focal plane. So we can change the focal plane here to match exactly what we had inside Unreal. And you can derive some of that information from the metadata. If we double click on the read node and go ahead and look at some of the information that's available inside of here, you can see that we have focal distance here is 83. And so we can take some of that information and extract it and actually through expressions just drive some of that. So if you had like a rack focus, for example, it could be driven per frame from the metadata of the camera. And as Matt had mentioned, we're doing some math operations to shift to get the motion vectors correct. So we're shifting those from red to green red, and then doing more of the math operations, as he had mentioned, to set up the motion vectors. He kind of went into detail on each one of those, so I don't necessarily have to show.
I think we lost Andy. Let's see if we can get him back. Sorry about that, everyone. Just a quick little interruption. Hopefully this is not permanent. Hope y'all are doing all right out there. How's the stream so far?
Sorry about that. Yeah, sorry, it kicked me off. I'll be back 1 second. Share screen again. Okay, can you guys see me? Am I back?
Yes, looking good.
Sorry about that. I got booted, so I'm back. And so we were taking a look at the motion blur here, and you can see now we've added blur into this background now from that depth pass. And you can also see inside of here we've added the motion vectors in, and I've added a grade node to kind of grade this down so we can see, because it was a little blown out in the render, but you can see now we've added those motion vectors in post-production as well. And so if I take a look at, say, the original render versus the Unreal render, you can see that we're getting a lot of that post-production still maintained in comp, that we can make all those changes with depth of field and motion blur applied. So that's a little bit of the Cryptomat side. I'm happy to answer more questions when we get to the QA section, or do more hands-on if people want. I'll show you the stencil layers in just a second, but I think Matt's going to explain more on the stencil layer option that we're providing as well.
Yes, so one of the new features is the stencil layer option. And so we've provided both the ObjectID and the stencil layer option as, ObjectID has some downsides, stencil layers have some downsides. We've provided both of them as they both work for different use cases. So one of the big ones is that the stencil layers do support post-processing. So you can get native engine depth of field and native engine motion blur. And so what we're doing when we do stencil layers is we're breaking the scene up into a user-specified number of layers, and which objects are in the layers is up to the users. And it's going to render the object against transparency or black. And you can see here on the right that the Newton's cradle from Andy's previous example is rendered against black, and you do have the nice motion blur around the moving parts. Foreground objects are going to obscure background objects. So if you have, your background plate, anywhere where there was a foreground object is going to have a black area. And that's so that the math works out for just adding them back together. The way we do this is when we render the entire scene, and then we use a stencil mask to clip pixels that don't belong to objects that are not in a current layer. And then we apply post-processing after that, and that allows us to have the correct depth of field and motion blur for each layer. So this is a visualization here of what the layer system would look like. We've broken up here where we have Newton's cradle as one layer. The next layer is the these vases or cups. You can see here on that layer that the Newton's cradle has a black spot where it is because it was pulled out. So looking at these in full resolution, which is a little easier, this is our background layer. And you can see that the foreground objects have cutouts again, but you do have the nice motion blur around them. Then we have the shelf in the background as a layer, the vases, and then the Newton's cradle. So how do you set this up? It's a little bit different. You're going to want to go to the use the editor's layer feature. So if you go to Window and then Layers, you can create new layers, and you're going to assign which actors you want in which layers. So you might have a foreground layer, a midground layer, or maybe you want to cut out a couple objects. So you just need to set them up and put them in a layer, and then you'll choose the layers later. Inside of Movie Render Queue, you're going to go to the Deferred Renderer, and you can add the layers as stencil layers. Excuse me. So when you add them as stencil layers, you hit the plus. There's a nice drop down to pick the layers you set up in the editor, and that's really all the setup you need. One thing we have added is a default layer, which you can optionally enable. And what this does is it takes any actor that is not in one of the specified layers and puts it in kind of a default background layer. And this is useful if you want to just cut out like 2 or 3 objects. You can put them on a layer, you toss the layer in, and then you render everything else without having to make sure you've added everything to the background layer, because that's a really easy way to accidentally, you add a prop, you forget to put in the background layer, suddenly it's not showing up in your render, so you're confused. So now you can just use the add default layer, and it'll just manage that automatically. So anything that is not in one of the specified layers will be shown in that layer. One downside to the stencil layer feature is that it increases render times by 100% for each layer. And we'll talk about why that is next, but it is something to be aware of, is that, adding one layer plus the default layer plus your normal render is now 300% longer, or 300% original time. So you do want to use layers sparingly, and not have one layer for every object in your scene, because that's going to take quite a long time to render. You will want to disable the tone curve. Layers do not add together correctly. If the tone curve is applied, you'll see kind of odd fringing and black halos around it when you add them back together. Another thing you're going to want to do is you're going to want to disable auto exposure. Auto exposure will happen in each layer, and because there's a different amount of black in each layer, it's going to change the exposure amount. So you'll need to disable auto exposure, use manual exposure to lock that down. So why do we go with stencil layers, and why are they called stencils? Unreal is primarily a deferred renderer, and certain effects in deferred rendering require objects to be drawn to have an effect on the final image. So things like screen space reflection, screen space ambient occlusion, shadow casting, they actually need to be drawn to be in the image. So you omitting an object from the render, such as like you wanted to render the background without the character. If you just turn off the character, the character will disappear from reflections. It won't cast shadows, it won't receive shadows. And so that's going to give you kind of a different look. And it's going to get very hard to integrate that into, put them back together, because you have the opposite problem is when you render only the character, they won't receive shadows from things that aren't being drawn, like the background. So the solution we went with is that we render the entire scene for every layer, and then we clip away pixels that don't belong to objects in that layer. So this uses the custom stencil feature in Unreal. It automatically turns on the custom stencil, renders out the stencil mask and uses it, and then restores your original stencil settings. So you don't need to worry about it. It all happens under the hood. But that is why it's called Stencil Layers, is because it does use the stencil buffer. So the pros to this method is that your scene is going to remain visually stable between no layers and many layers. And that just means that, if you put the character on a layer, it's still going to show up in the reflections for everything around, versus if you hadn't put the character in the layer. Again, objects remain in reflections and provide other contributions, even if they're not present in the final image for that layer. cast shadows, things like that. We support depth of field and motion blur and TAA because we do this clipping of the images before any post-processing is applied. And finally, if you do have the alpha channel stuff set up correctly, you can get an alpha channel that contains a mask of the pixels that were actually written to for a given layer. And as I said earlier, we render against black, but when you combine that with the alpha channel, you can use that as a mask for certain grading operations like gain or offset, I think it is, that would normally lift the blacks, and then when you add them together, you've lifted everything. By using the alpha channel, you can mask that out so that it doesn't lift things that don't belong to that layer. So what are the downsides? Well, the render time goes up by 100% with each layer. So it is something you want to use sparingly, but it's a pretty good solution for a pretty hard problem. So Andy will go through actually showing this in a demo, but if you were to use it in Nuke, you're going to want to color correct an individual layer. You can use the alpha channel as a mask. You combine them back together with plus, so that's just A plus B plus C, and it requires the tone curve to be disabled for them to add back up together. Now I'm going to turn it over to Andy to give us a really cool demo on Nuke.
Cool, thanks, Matt. So yeah, I had taken one of these renders, and I'll show you broken it into a couple different stencil layers. And so if I look at just the raw image, I have the apartment scene here. I've created a stencil layer. If I inspect the alpha channel, you'll see, as Matt was talking about, this white and black mat that's in the alpha channel. We store the information. So if I look at the shuffle node, you'll see it says final image, the foreground prop. So that was the name that I called it inside of Unreal. And you can also see there's a coffee table. So in this coffee table, this render here, I have another shuffle node. And if I preview that and show you, I have just the alpha channel of the coffee table objects. So I'm going to take those two and I'm going to put them in front of this background. So we're plussing those Matt was saying on top. And then I did a simple, I wanted to insert something in between. So I have a guy here that I put sandwiched in between there so that if I take, say, this transform node and have the little gizmo here, you can see that I could place him behind those foreground objects. And in fact, if I want to put him behind that coffee table, I have the mask ID to do that as well. So allowing you to set up these layers allow you to kind of sandwich in some of the traditional media stuff way more easily and target those. Plus we get, as Matt was saying, you get the depth of field, for example, on top of some of these leaves baked into the render and working correctly. So there's a lot more of the post-production options available. I'll just kind of move him over here. And it's pretty straightforward in terms of just setting up your renders inside of Unreal as far as the layers go. Those come in as the channels on the multi-layer EXR. I can use that shuffle node, as I said, and just extract the different elements that I want. And then I can pull those out as masks. And then it's just a matter of setting up some of the compositing logic like you would typically do inside of Nuke. And so, yeah, same thing. I can kind of go into deeper detail if people want at a later point. But yeah, that's the basics of it, is that you can use those alpha channels then to isolate the specific parts of the image that you want.
Cool, thank you very much. And can you actually zoom in real close on the showing how the depth of field works nicely over the background plates with him? I think it's a really cool effect. I just want to make sure people are able to see it since your view portion on the screen is not as big.
Mm-hmm.
All right, so the next thing we're going to talk about is we're going to talk about OpenColor I/O workflows. So OpenColor I/O is generally a pretty advanced topic. So for people who are familiar with this will hopefully all make sense. If you're not familiar with OpenColor I/O, Andy will be able to give us some background here in a second on what it's used for. We don't cover creating OpenColor I/O workflows or sorry, we don't cover creating OpenIO, OpenColor IO assets because the creation process is rather long and complicated. So that's kind of the area where if you're using it on your project, and it'll make sense. And if you're not using it on your project, you probably don't want it. So I'm going to turn it over here to Andy for a second. He's going to give us a little bit of background on OpenColor IO.
Yeah, so OpenColor IO is a standard that was developed mostly for the film industry in terms of it's a way to standardize color management across a pipeline. So in a film, and especially VFX type pipeline, typically you're dealing with a media that's coming in from a film camera and shot in various kind of color spaces. And then you have a CG world where you're doing lots of your renders, and you're also doing compositing, which has another kind of layer of complexity for a color pipeline. So OpenColor IO has been used all throughout the visual effects industry to standardize these. And something, as I mentioned earlier, that we started to support a few releases ago, but we now support in a few different areas. One thing I'll get into the movie render queue side of it, and then in the viewport in just a second. But some of the things to note is, typically this could be so that you can work in linear space, but you could see what the overall LUT applied to the film is going to look like. Maybe there's been a grade that's been done by colorists that the director loves and wants to see applied. And so it's a way to work without those color transforms applied directly to, and so there's the idea of being able to preview it, but then also render media from it. So the editor supports OpenColor IO now in the viewport. And so if you advance to the next slide there, Matt, we have the ability to, under your view options, turn on OpenColor IO. And as Matt was saying, we don't necessarily cover it in great detail, but you do need to enable the plugin, and you need to download an OpenColor IO config. If you go to Google and search for OpenColor IO, you'll see that there's a web page, and it comes with a set of zip folder with basically a prepackaged set of LUTs that you can use. And inside of that, you're going to want to grab the OCIO config file. And then in Unreal, you want to create an OCIO asset and point it toward that config file. Once you have that config file, basically it gives you access to a lot of different color spaces. And there's this idea of source and destination. And so you want to say that Unreal is rendering in linear, but I also want to display it as RE log footage, for example. And so you would take the source as linear and the destination as the RE log, and that will change the viewport to look as though you're looking through a RE log color managed image. And so that's the first place we've added it in this release. The second place is in the movie render queue. If you want to go to the next slide there, Matt. And in the movie render queue, you have the ability to render out with it applied to the media. So under the settings tab, you can select color. And then it's a very similar process. You just point it towards that OCIO asset, and you select the source and destination. And so under the destination, you can put your output color type. With this, if you don't want the tone curve applied, there's the disable tone curve. And as Matt, you may have to correct me if I'm wrong here, but for our linear outputs, I think when OCIO is enabled, it just disables the tone curve automatically. Is that correct?
Yes. So if you're using an OCIO profile in general, OCIO is taking over the destination color space. So OCIO is always going to expect a linear sRGB input, and then the destination color space is up to you. Here we've done Canon log, but if you were to not use OCIO and just disable the tone curve, that's how you would get linear sRGB out without using OCIO.
Yes. So you can manage your renders now much more effectively with color space management. And So we recommend, in terms of the high-end kind of clients that are looking to utilize, I guess, those kind of features, this is the best way to go about it.
Cool. And I just want to clarify some of the points that we have here on the slide. So as Andy mentioned, that OCIO is for transforming from a source color space to a destination color space. Unreal does not use this by default. By default, Unreal applies a tone curve, and this produces a result that's similar to ACES, but it's not exactly ACES. And there is a way to try and get it closer to ACES through post-production, and that's something that we could post on the forums later if you guys need to see it. But it's still not going to match perfectly in Unreal, so it's really a good idea to use OCIO to preview in the viewport whatever your final one is going to be, author your content with that in mind, and then rendering it out. So Andy talked about the viewports having the OCI profile. That is just a preview on the viewport itself. It does not by default affect the movie render. By default, the movie render is going to go back to the Unreal sRGB, linear, not quite ACES output. So if you want to render out from movie render queue with the OCIO profile applied, say you wanted to, you want to render out some PNGs and show your boss what it looks like with the color from Unreal, you can use the OCIO settings there to have it apply that profile to the output PNGs. Or you can render without it, and you can render with just tone curve disabled, and that'll again give you the linear sRGB. Then you can take that linear sRGB image into Nuke and apply your color grading there in Nuke, or your OCI profile in Nuke, to get into your destination one. So those both options are there. It is, again, up to you once you start using OCIO what your output color space is in. Okay, so that covers our OCIO there. Next thing we're going to talk about is post-processing materials for GBuffer data. So this is something that people have asked for in the past, and there's some confusion around it. So we just wanted to talk about it, clarify it, and show you how to do it in 426. So big picture, what is GBuffer data? The GBuffer is it's how deferred renderers work. It's called a global buffer. It's what the G stands for, I believe. What it is that when we render a scene in Unreal using the deferred renderer, we store things like roughness and normal and depth and specularity and emissive. We store all those into some textures. And then once we've rendered all the objects in the world with those into those textures, we then apply a pixel shader that samples from all those textures and builds your final pixel as you see in the viewport. It's a very simplified version. There's a lot more going on. But people sometimes want to access this GBuffer data because they want to say, hey, I'd like to know, I'd like to get the base color for this scene. And so what people run into a lot is that the way a GBuffer works is that it's a single sample per pixel. So that means there's no depth of field, there's no anti-aliasing, there's no motion blur. And this is because if you take a depth buffer and you apply anti-aliasing to it, the values are no longer depth, right? It's an average between the front and the back, and that doesn't make any sense. So that's something to be aware of, is that when you do access GBuffer data, it is single sample. However, if you're using multi-sample accumulation in the movie render queue, we are going to be averaging those results that we get back out. We talked about earlier with the kind of anti-alias depth buffer for depth of field. Again, it's not technically correct because those pixels no longer have the correct depth values. But now with the multi-sampling stuff, you can start to get access to some of those GBuffers and apply a form of, anti-aliasing. Again, it doesn't make sense in all cases. Like if you take world normals and you average out world normals, like that doesn't make sense on edge pixels. And you still do not get post-processing or, you don't get depth of field or motion blur, chromatic aberration, stuff like that. Because once Unreal has read the GBuffer and turned it into kind of your final pixels, it's now just a 2D image, and then we take that 2D image and then we apply post-processing to it to do anti-aliasing, depth of field, motion blur, chromatic aberration, color grading, and stuff like that. So in 426, let's take a step back here. So how do you do this in the new movie render queue? So in the new movie render queue, we have the new in 426 under the deferred renderer. We have the additional post-process materials array. And what you can do there is you can slot in a post-process material. And when we render your scene, we will then run that post-process material and we will save the results up to a separate texture. So by default, we talked about the world depth and the motion vectors. We provide some other ones. We have world normal, ambient occlusion, world position. You can make your own. We just ship a couple of defaults for you, but really just any post-processing material, the blendable location set to after tone mapping, you can do. Keep in mind that the data coming into the tone mapper, if you're sampling from the screen, or sorry, the data coming into the post-processing material, if you're sampling from the screen, is going to be in linear sRGB, while if you're in the viewport, it's coming in as sRGB. So once you make a material and you slot it in here, again, it's going to get run. By default in 426, all the output is in 16-bit. And so this is okay in most cases, but you can run into problems with using really large depths or world position when you're not very close to the origin. That's going to give you, you're going to start seeing kind of stepping. So 426.1, not quite out yet. You'll be able to enable 32-bit options using two console commands, r.buffer visualization dump frames as HDR 1 and r post-processing color format 1. When you set both of those and then render a movie in 426.1, the output from the post-processing materials will be 32-bit, sort of. The reason I say sort of is that it depends on what your source data information is. I believe the depth buffer is only 24-bit. Don't quote me on that. So you can take 24-bit and we can output it as 32-bit, but you still only have 24 bits of actual data. So even though we are 32-bit output, you're still limited by what resolution or what precision your incoming data is. As I said, we ship with some defaults. You can add your own. You can just look at these to see how to make them, slot them in, and you can get access to the GBuffer data. All right, so this is our last section before we do another Q&A in the presentation. We're going to talk about some best practices. And this is just giving you some things to think about for different workflows so that you do it right from the get-go and you don't have to run into these later, start looking at the troubleshooting section of this because you're not sure what's going on. So we have lots of workflows now. We support a wide variety of workflows, and you need to know what kind of watch out for in different workflows. Some of our workflows they're not really hard and fast categories, but we consider like if you're rendering out really large screenshots, that's kind of different than rendering out a game trailer. If you want really smooth motion blur, that's kind of different. And if you're doing post-production using Nuke or other software, those again have some other things to worry about. The various features like temporal subsampling and spatial sampling have side effects. Temporal subsampling gives you more renders. And so they all have side effects, and it's really important that you experiment with them and see if it does what you want for your particular workflow. General good practices, be careful with turning all the settings to 11. So this is something that people run into sometimes where they use numbers that they've used in other software. They might have come from an offline world where they're like, oh, I need 64 or 128 samples to get nice clean renders. Because we are predominantly the real-time engine, and generally we look pretty good with only a single sample, you really want to be careful with turning this up. If you go into the temporal samples and spatial samples, you start increasing your ray tracing bounces in large increments, you can end up with really slow renders. And there is, I think, to some extent, diminishing returns after some point, as we kind of saw earlier, where 8 temporal samples didn't look too much worse than 16 temporal samples. And then if you did 32 temporal samples, the difference is going to be smaller. So play with the numbers and just play with them, like try 1 temporal sample, try 5 temporal samples, or whatever. Internally, we use 8 to 16 temporal samples for 95% of the shots in Fortnite trailers. So that is a real world use case here, is that most of the time we don't go above 16. Everything else is really just camera settings, and occasionally there's CVARs that are executed to fix some things of like sorting and stuff like that. It is content dependent. We try and pick the best defaults in general, but since it's content dependent, it's not always that. Different content is going to need different settings. So if you have lots of shadows and you're using ray tracing, you might need more samples for denoising than you do in other shots. And that's why we have that per shot override stuff now, is you can go in and say, for this shot only, do 16 temporal samples. Shots with very fast camera movement may need more temporal samples. Again, if you have like a really fast camera pull, you're going to add in lots of temporal samples, and it's going to give you this really nice smooth one, but you don't need that many temporal samples most of the time. One thing that's important is test temporal samples early if you can. The big difference between not using temporal samples and using temporal samples is we tick the engine 8 or 16 or 32 times for every output frame. And it's easy to accidentally write game code or particle code that doesn't respect delta time. And then that's going to give you a different result when you use more temporal samples. So every now and then kick off a render with 5 or 16, take a look at it, make sure it's doing what you expect. All right, so if you're creating screenshots, you're really just interested in like really nice, really high resolution, automotive renders or architectural visualization renders. Somebody's asked you to print an image that's as large as a building in real life. You're going to want to do this, high resolution screenshots. So we now in the movie render queue support single frame long sequences and camera cuts. In the old movie renderer, you had to have kind of warm up frames, and motion blur wouldn't work on the first frame, and there's all these workarounds. We do our best to emulate all of these automatically now. So you can make a camera cut that is 1 frame long in sequencer, and you should get a nice looking image right out of the box. There are high resolution tiling limits. As we talked about earlier, any post-processing effect that requires looking at the whole screen or frame history. So that's going to be TAA, SSR, convolution bloom, auto exposure, lens flares, and some others. Panini projection's not going to work. Just be aware of those before you make all your content. You can turn them off in your post-processing volume, and then when you're making your final look in the editor, you can get, end up with the same result in high resolution render versus the output render. With high resolution screenshots, you can use a higher tile count to reduce the size of each render. Reducing the size of each render is going to reduce the memory consumption, and it's going to reduce the likelihood of DDR. One thing to keep in mind is that the default behavior in the editor for resizing viewports is that once you size a viewport up, it does not by default resize it down. And that's to avoid hitching, especially if you're in the editor and you're like resizing that main viewport all the time. Instead of reallocating all the memory, we only allocate it when you get bigger. What that means for movie rendering is that if you render a 4K image and then you try and go in and say, oh, I have 2 tiles to make a 1920 image, it's still storing the memory of that 4K. It's not rendering at 4K, but still use that memory. So if you do play with tiles and you are having memory consumption issues, try restarting the editor after you have tried, once you have a larger image and you go to a smaller image, restart the editor before you render the smaller image. In this case, if you're making screenshots, you probably can't turn everything up to 11. Generally, if you're only making one screenshot, it's not going to matter if it takes 10 or 15 minutes. As you saw earlier in the presentation, it only took us 7 minutes to render a 32,000 by 17,000 image with 16 samples. It's very fast compared to a traditional offline rendering package. Andy, I don't know if you have any ballpark figures of what that might be in an offline package.
Yeah, I mean, renders like that can be hours long. It could be plus 1 hour for, a render like that in an offline package.
So if you're creating trailers, you've moved out of the single screenshot realm and you've moved into the many screenshot realm of movies. Trailers are going to get a little bit more complicated because they're kind of turning into a bit of a game. Unreal Engine has a long history as a game engine. So you do need to start considering some of the side effects of being a game engine as you go forwards. For trailers, you're going to want to utilize cues, master presets, and shot overrides. Internally for trailers, we usually use a single master preset for the whole trailer, and then we'll use a shot override for a few shots, which need more temporal or spatial samples. Then we save this into a cue asset, we check that in, And now any artist can open up that Q asset, import it, and they're going to get the exact same render settings as everybody else. So that keeps everything nice and consistent. An artist looks at his work, and it's going to look the same when the render manager guy renders it. If you're making trailers, test more than one temporal sample early. It makes it easy to catch content that's not been extended before the first frame, or particle issues, or cloth issues. If you are using cloth or particle effects, ensure you have data before each shot. Evaluating the data by using the Use Camera Cut for Warm-Up setting solves all sorts of first frame issues, so it's important to do. So basically, where possible, try to have data before the start of every shot that's just outside of your playback rated sequencer, and then use the Use Camera Cut for Warm-Up so that you actually evaluate that when we do a render. For a trailer, you can consider turning off auto exposure. Exposure generally is going to settle out during the warm-up frames, but if you were to turn down your warm-up frames to some small number, you're going to get different exposure at the start of a shot than the end. So as you go forward as an artist, just have your artist change the cameras to manual exposure, and that's just going to give you consistent results. If you're looking to do smooth motion blur, this is probably the very high return for the least effort. You add the anti-aliasing setting, you set the temporal sample count to 8, and you get some nice looking images. You can get even nicer images by disabling TAA. So TAA works pretty good for real-time situations, but it can struggle when you have high noise backgrounds. So if you had like a grate or just really noisy backgrounds, TAA can sometimes struggle, and you can sometimes see visible ghosting or trailing behind objects. So disabling TAA and using the temporal samples is going to give you a really nice anti-aliasing. But disabling TAA does make the ray tracing noisers less effective. The ray tracing denoisers rely on the TAA image history to be more effective. You can technically leave TAA on and use temporal samples. It's not technically correct, and the UI is going to try and warn against it because the math is no longer correct, but it looks correct and looks good in many cases. So it's up to you if you're willing to, cheat a little bit and end up with nice looking pixels that aren't technically correct. Using smooth motion blur doesn't work with motion vectors in post-production. Again, because your final output for a frame is 8 images that have been rendered, and we've just stamped 8 copies of the image onto that final frame. You've got 8 copies of your motion vectors. It's going to end up giving you like really odd results, and it's not going to end up with what you want. Finally, if you're doing post-production in Nuke, 426 adds a lot of power in this regard. If you're doing stencil layers and object IDs, you're not going to get exact matches to what you see in Engine. We've done our best to get pretty close. This is all based on physically based cameras, and most other packages are. And you get close, as we saw with Andy earlier, but you're not going to get an exact match. So if you are going to do these workflows, you should probably test them often to make sure your artists are giving you the right final look in Nuke instead of the final look in the editor. Again, operations should be done in linear space for most post-production. There is no perfect way to convert back to Unreal's look because it's not quite ACES. A lot of the post-production workflows you should probably use in combination with OCIO support so that you can make a look that you use both in the viewport and in your post-production software. And that way you can edit your content with the viewport preview, render it out in linear, do all your depth of field changes, and then reapply the look to have it go back to looking like the editor viewport. For the post-production stuff, the math is all really, really, really tricky. There's a lot of ways you can go wrong in subtle ways. I discovered the hard way about 7, 8, 9 times, just trying to get to the field working. So make some simple test cases and verify the results. Make sure your motion blur is scaled correctly and goes the same way in Unreal as it does in Nuke. Make sure your depth of field is the right size. One way to test this is you add a job to the sequence. You go in and you say, I want the depth and object ID and and you turn off the disable multi-sample effects in Unreal, accept the job, duplicate the job with Control W, open up the settings in the duplicate, turn off the disable multi-sample effects, hit OK, render both of them. Now you can take it into Nuke and you can see what did Unreal come up with as an answer for the depth of field on this? What did your Nuke script come up? And that's a good way to, kind of do an apples to apples comparison. In general, though, you're going to want to make your changes in Unreal as much as possible. The power of real-time editing and fast renders makes doing this a viable option. These renders are minutes long instead of days long or hours long. The more you do things in Unreal, you're going to get more correct results. Global illumination would be influenced by the color of objects. Reflections are going to be influenced by objects, things like that. And so the more changes you make in Unreal, the more correct everything else is going to be in the scene. And I think that concludes the presentation, other than some more Q&A.
All right. Thanks a lot, Matt. That's quite a bit of information there. For all of you watching live right now, if you're hoping to sort of digest this in a slower pace, be able to pause later, the video is available on Twitch immediately as soon as we go offline, as well as on YouTube within the next 24 hours. We had some issues today, that's why we're not streaming to YouTube, but it will be up as part of the Inside Unreal playlist as soon as we can get it up. Let's move on. We got a couple questions here for y'all. Starfish7985 asked, "Hi Andy, will you add material elements for the object ID pass? Like if an object has several different material elements?"
Yeah, that one's a bit tricky. Obviously, that is part of the Cryptomatte standard. It's difficult for us to kind of compensate for that. So, and Matt, you can kind of correct me on the technical things if I misspeak here. But I mean, we, in a sense, have to replace every a material that's on that actor and re-render. And so there's a big cost to that at this point. It's something we had kind of brought up during development, but, it wasn't feasible for us to be able to support all of that initially. And so we're like aware that that is part of the standard, but current kind of limitation is, we're sticking to the actors and the components, but we would love to be able to have support for each individual material that's assigned to that mesh as well. It's something that is kind of like on the roadmap, but pushed to the back until we can find a better solution at this point.
Rabia Rob asked, "How do you prevent duplicated object IDs in a Cryptomatte pass?"
So we generate, we try and generate stable object IDs based on the path in the world outliner. So if you have a folder and your actor's in a folder, we go with folder name and actor name and component name. So if you have two shelves that have exact same names, or sorry, two models that have exact same names, you will get a collision in the object ID generated object IDs. And actually, if we want to switch over to Andy's screen real quick, you can actually see with the Cryptomatte picker and the field above it, actually, you can see that we've have the names of the actual objects. So you do see the names of the objects in Nuke.
Give us a moment, Matt, so that we can just switch over.
Yeah, no problem.
I'll keep talking and then we'll go back to that. So how do we prevent collisions? Is it's based on the name. So as long as things have unique names, it should work. That's also how we try and have stable IDs across multiple renders, is that we take an object and we generate the ID from its name, and then we save that ID into the file. And so in general, there are still some issues with this as an experimental feature. In general, it tries to keep stable names so that your Cryptomatte mats continue to work after you re-render.
Yeah, and you can see, I guess what I'm trying to show on my screen is that when you select with the picker and there's a mat list in the Cryptomatte node that will give you those names that Matt was talking about here, for example.
Yeah, so it'll show you the original name, the folder path and name that was in Unreal, which is handy if you want to go back into Unreal, find the object, and change something about it. Next question.
All right.
Yeah, so I think we're good on that.
Cool. I heard switch to Unreal, so I was waiting to see Unreal pop up on the screen.
Okay.
Vandal Savage asked, "Are all the USD features also supported in the MRQ?"
did see that one pop up in chat. I'm wondering a little more what he is thinking about for the specific USD features. Currently, there's no real USD features in the movie render queue. It's more about the import process and that kind of thing, but I'm wondering what he has in mind on the export side. So maybe follow up in chat there.
Keep an eye out for that. Vandal Savage also asked, are there any plans to support panoramic renders from the movie render queue in the future?
So this is something that... Okay.
I was going to say it's been requested quite a bit, as far as, I mean, Matt can kind of talk to the specifics on the technical side, but, I would say that's definitely one of the highly requested features by everyone.
So I just wanted to throw in that, yes, it is a highly requested one. There is some complicated math because, again, we have the high resolution tiling feature. And you're going to want those to work together. You can actually create new render passes as plugins for Movie Render Queue. So if there's anybody out there in the industry who's looking for a plugin opportunity for our marketplace, you can write a panoramic render pass and plug it in without any engine changes.
Cool. See, Poco3D asked, is there a way to render CryptoMat with volume objects, transparent objects, and particles?
This is not something we support currently.
Yeah.
Again, it goes back to the blending multiple IDs thing on the GPU is very complicated.
Yeah, would you suggest, Matt, in that case, the stencil IDs the better option at this point?
You can use the stencil IDs, and something we didn't. Andy touched on briefly earlier. If you go into Unreal and you delete everything in the background, so you delete the atmospheric fog and you delete the sky dome, so you're seeing like the black void of the editor. If you have the alpha options enabled, you actually can render out the scene with that alpha. So what you can do is you can kind of get creative with having transparent objects against an actual void and rendering that, and then that's going to give you an alpha channel that matches that transparent object. But you have to render it against the void, because if you have an opaque object behind it, then it's going to pick up the alpha channel from the opaque object, and you're not going to end up being able to tell. So you can maybe come up with some sort of workaround, but it's a very complicated problem. It's not something that we have an ETA on.
Elfiant asked, in OCIO, what settings should I choose if I want my footage to be linear?
So Unreal always outputs in linear sRGB, or sorry, take the sense back. When you're using OCIO, or you've disabled the tone curve, Unreal always outputs in the linear sRGB space. So when you say that you want linear, I think there's more to that question of like linear with what space on it. So just know that Unreal is in linear sRGB, and then you can use the OCIO to create a different transform. Andy, do you have something there?
Yeah, I think if you have my screen, I don't have it fully set up to show. I can show that I have an OCIO config here, and you can have linear sRGB as the source color space, and then from one of the OCIO configs, you would want to output as linear, just as this is here, and that would do the conversion for you. But I've only added a couple of these in. It might be a good time for me to show a little bit of that too. I set that up while you were talking earlier, because I saw that there was a couple questions, but the very basics of it is that when you have the plugin enabled, you will be able to right click and go into miscellaneous. You'll have an open color IO configuration, and I've went ahead and created a couple of those, and there were some questions on ASIS and others. And so I've downloaded an OCIO config already from the website, which I saw was posted there in chat. But you can see OCIO comes with a bunch of configurations, which ASIS is one of those. So if I go all the way back out and I go in, you'll see that there's ASYS, several versions of ASYS, but ASYS 1.3 here I'll select, and you want to select the config, OCIO config, and click OK. And then in here I can select a bunch of color spaces that I want to use. So when I hit the plus button, I can go ahead and specify those color spaces. So I've already added a few of them, like ASYS CG, for example. And then I'm just going to delete this one out because I'm not using it. I'll save and close this asset. And then inside the movie render queue, as Matt was saying here, when I click on the settings, I can add under color here, we can add that, and we can enable the config. And then we can select that this was from a linear sRGB. And for example, we want to render an ASYS CG. And so when I enable this, this will disable the tone curve and it will render out my images as ASYS CG. And to kind of complete the loop, I wanted to show you in editor here as well, like we were talking. We'll see under this lit option, you'll see this OCIO display at the very bottom. This is where I could turn on that, and I've selected the ASYS OCIO config. I've said that we're linear sRGB and we want to go to ASYS CG. And when I click enable, you'll see that the viewport has been updated. So my render should look like the viewport's looking like now. So if you wanted some kind of color managed workflow of seeing what you see in the engine and then to the output, that's the way you would go about doing that.
All right. Let's dig into the last two here. Scott VR was wondering, cleanest way to export all audio, multiple tracks, voices, music, etc. in a sequence, since audio not supported for many formats in movie render. How to sync in editor if you frame handles rendered.
So this is a audio capture is complicated, and what we do is the new Unreal audio mixer actually allows you to capture submixes to an audio file, and so by default we only capture the master submix, and that's what the audio recorder is recording. As we talked about earlier, there are still some limitations, gaps between the shots. And even when you try and, like, if you have an audio clip at your master level and you render out all the individual shots, what you're going to do is it's going to, because it's not a sample perfect playback, you will hear little blips to it. Probably what you want to do is, if you've imported all your audio into Sequencer, if the tracks are on Sequencer and if you have the original audio files on disk, so if you look at the audio asset and the import path is somewhere on disk, when you export in XML, it will create audio tracks in Premiere or your other software, and it will try and point to the same wave file that you imported the wave into Unreal from. So that's kind of, instead of taking kind of the real-time audio, that's going to take you the same source audio and put it into Premiere, and it should give you a similar result to what you see in Sequencer if you were just to hit play. Obviously, you don't have the background sounds from the world, but you'll be able to put those into Premiere by hand.
Discovered we had another question from the first QA pass that I didn't get to, so let's make sure we cover those as well. Saiho asked, when memory swapping happens, is there a notification happening from the renderer, or do we need to look at rhi.dump memory to figure out that it's not fitting into the VRAM?
To be honest, I don't know if there is any notification even from the APIs itself. Unfortunately, it's just something you have to look at probably, and you probably want to look in Task Manager. We have the RHI dump memory. It's an approximation. There are some types of memory used that are not necessarily tracked in that, and Windows is going to give you a closer result to what's used, because Unreal is only going to track obviously what Unreal uses, and Windows is going to track everything that every program uses. And so you're really going to want to look in the Windows Task Manager. Unfortunately, I don't know of any way to know when swapping has happened. Not all hardware configurations do it. Some just run out of memory. So really, if you see that your numbers are going really close to that, so your upper limit, or if you start seeing, I think it's called shared GPU memory, one of the other fields there combines both system memory plus GPU memory used. But on a slide here, if I can find the slide. Oh, you may not be pointed at me. That's fine. There's a field on the thing called GPU memory, which is a combination of both dedicated and system memory. So short answer, I don't know if there's any notification. You have to keep an eye on it. One way you will know is if your renders suddenly get really, really slow, is you've probably run out of memory and it's probably doing swap.
All right. Gonna make sure I didn't miss anything else that I was planning to ask. If I can find the right window. This might not be a short question, so let us know if that's the case. But Poco3D asked, can you show quickly or explain how to render sequence with different setup for each shot controlled by levels using the queue?
Show shot masks.
I think
different levels, though.
I think what they're looking for is they want to modify the level sequence, perhaps, between each render. I'm not totally sure on the request there. What we will look at is the slide on, if I can find the slide on Runtime Support, because this does kind of give us an idea. Can you guys let me know when we switch the stream back over to point at my screen?
See, just a moment. Yes, we got you.
Okay, so this is the how you use blueprints in runtime. It says runtime, but or shipping, you can use it in Pi in the editor, just like it does in the final game at Previous correctly. And what you can do, is you can construct the queue, allocate the new job, do the configuration, wait for the execution to finish, and then change it. This is probably something that might be easier in Python. Sequencer scripting is a little bit easier to access in Python. In Blueprints, it requires a lot of casting nodes. So it might be better to set this up in Python where you do a similar thing here, and we have an example in the folder. You set this all up, and then when the render completes, then you make whatever changes. You can either change the sequence data itself, or you can change the editor. And then when you launch the next Pi session to render, that's going to use your modified sequence. If you're modifying the sequence itself at runtime, that gets into definitely complicated territory. Because if you want to do a shipping build, since we don't support Python, you're going to need to use C++ to directly access the sequencer stuff. I think that encompasses most of that.
You tell me.
Yeah. Well, I was just going to clarify too, is that you don't have to just render like one map and one sequence. It could be like, multiple levels or maps. And that's why it's kind of a batch rendering queue system. So if you are rendering, one sequence and then another one from a different map, you just have to load those up in the queue and those will render. And obviously we kind of covered all the shot specific stuff that you can override, but it doesn't stop you from rendering two different levels with different sequences that you have set up in the project.
All right. Well, with that said, first off, I want to thank Matt and Andy for coming on the stream, spending, that was 3 hours. You hit the 3-hour mark. And we've been there for even longer. I think we're all due time for maybe a little bit of dinner and maybe a second cup of coffee. For all of you out there who are watching and stuck around with us from the beginning, thank you so much for hanging out. If you're new to Unreal Engine and you're curious about what game development and movies, virtual production, everything that you now can do with the engine, check out unrealengine.com, where you can download the launcher and then the engine for free. There's also learn.unrealengine.com, and there are not hundreds, I can't say that technically, but there are over 100 courses or videos where you can learn everything in the engine, from gameplay to how to render out videos and all the other exciting stuff. Andy and Matt, is there anything you wanted to leave the stream with before we say goodbye for today?
I do actually have something, because your comment about videos reminded me. So in the UI overview, if you've used the old sequencer render before, you may be familiar with this clipboard icon in sequencer. Even if you've enabled movie render queue, Pressing that clipboard icon in Sequencer is going to open the old UI and the old renderer. So for now, you need to make sure you go through Window, Cinematics, Movie Render Queue. In a future version, we're hoping to have replace that button to make sure it opens the Movie Render Queue. And just wanted to call that out since sometimes people get confused because they press the button, they get the old one, and they're like, what gives? Forgot about that earlier in the talk.
There might be a few more of those. Andy, Matt, if there's anything else you want to fill in after the stream, you can do that on the forum announcement post on the forums. That's also for all of you out there where we announce the live streams that are coming up. You can go to the event section of the forums, and that's where we continue the discussion around the topic post-stream. So feel free to continue to drop questions on the forums in regards to all of the live streams, and we take a good look at them. We do transcripts for all of the live streams. So in case there were a couple of terms that you weren't familiar with how to spell and you might want to go Google them, within a week after we upload a video to YouTube, we do a manual transcription of the entire stream. We upload them as captions as well, so you can turn those on YouTube. But what's really handy is that you can download the transcript and you can do a Control F, search for terms that was spoken, and then find the timestamp related to that sentence, and then go take a look at that. We also timestamp all the videos on YouTube, so that's also another good place to go when you want to watch the video after we're live. Make sure you visit communities.unrealengine.com if you're interested in meeting other like-minded people who are working with Unreal Engine. No one is doing any physical meetups right now, but plenty of the groups are spinning up virtual meetups inside their own Discords. It can be a good place to find and connect with some people who are also interested in Unreal Engine. We do community spotlights every week. Make sure you let us know what projects you're working on. You can reach us on Twitter. Forums is a good place to PM us. Also, make sure to check out unrealslackers.org. It's our unofficial Unreal Engine Discord community. A very large group of helpful people and good discussions. If you stream on Twitch, make sure you use the Unreal Engine tag as well as the game development tag. That's the best way for us to find you when you're streaming. Check out your content. Hopefully, we'll go ahead and raid someone today once we're done here. Then make sure you follow us on social media. And next week, we are going to announce the winners of the 2020 Epic Mega Jam and play those games on stream. Hopefully, all of that will go well because there's going to be a couple of us on the call, and we're all going to have to screen share. But it will be exciting. At least I'm excited for it because I've been playing a lot of games in the past couple of weeks. With that, I think I'm done. Andy and Matt, thanks again so much for doing this presentation. Oh, I do want to mention that Matt's slide deck will be available for download on the forum announcement post under the resources section, maybe within the next 20 minutes or so, as soon as I'm able to get it and get it uploaded there. With that said, stay safe, everyone. Say goodbye to Matt and Andy, and we will see you all again next week. Take care.
Thank you so much.
Yeah, thanks for coming out and listening to me talk for 3 hours.
Bye.